Hello guys and welcome to TechWolf. In this video we are going to start a full course of Cisco Packet Tracer. We will be creating different network scenarios using Packet Tracer, we will install Packet Tracer, we will go over UI or user interface of Packet Tracer, but in this video I am going to give you an in-depth understanding what Cisco Packet Tracer is, as it is also useful to know to in-depth understand what Cisco Packet Tracer is before we dive into the course. So, Cisco Packet Tracer is a powerful network simulation tool created by Cisco Systems, and it is primarily used for network design, configuration, troubleshooting and simulation in virtual environments. This tool is particularly beneficial in studying computer networking and preparing for Cisco certifications such as the CCNA or Cisco Certified Network Associate and CCNP, Cisco Certified Network Professional. Let's dive in how Packet Tracer works, its benefits in studying and real-life applications. So what is a Packet Tracer? A Packet Tracer provides a virtual environment where users can simulate complex network configurations without the need for actual hardware. So in general, by using Cisco Packet Tracer you can create real-world scenarios without devices. It includes features for configuring routers, switches, wireless networks and other network devices, allowing users to see how data packets move through a network, for example TCP/IP or UDP connections, interact with devices and troubleshoot network issues. And here are the key features of Cisco Packet Tracer. Simulation mode. Simulation mode allows users to see packet by packet flow through the network. Next one is real-time mode. And real-time mode enables immediate feedback on the functionality of the network as configured. Then we have multi-user collaboration. Packet Tracer users can work on the same network setup in real time, and this is ideal for collaboration, study and team-based projects. Next feature is wide range of devices. It allows simulate routers, switches, PCs, IoTs or Internet of Things devices and more. Command line interface or CLI in Packet Tracer offers practice with Cisco command line syntax, which is essential for real-world configuration. And here is the example of Tracer in studying. For example, a scenario: a student learning for the CCNA certification can set up a virtual network using Packet Tracer to simulate connecting two local area networks or LANs through routers and switches. And here is a step-by-step look at how this might work. In step 1, network setup, the student places two PCs, a switch and a router on each LAN or local area network and connects them through Ethernet cables. IP address configuration, the student assigns IP addresses to each device in two networks and sets up a subnet mask and default gateway to enable inter-network communication. And step 3 is router configuration, where using the CLI or command line interface, the student configures each router with the necessary IP addresses and routers to enable packet forwarding between the two LANs. And in step 4, testing connectivity, using Packet Tracer simulation mode, the student sends a ping from a PC in the first LAN to a PC in a second LAN. And Packet Tracer shows each stage of the packet journey, highlighting issues if the configuration is incorrect. And finally, troubleshooting. If there is an issue, the student can trace where the packet fails and adjust the configuration as needed, learning from the real-time troubleshooting. This hands-on experience is invaluable in mastering network design, configuration and troubleshooting techniques without using physical network hardware. And not to mention that Packet Tracer is absolutely free. And here I will also give you an example of Packet Tracer in real-life scenario. Well, Packet Tracer is primarily used for educational purposes. It has a few applications in real-life network design and management. And first would be network design and planning, where network engineers can use Packet Tracer to prototype network setups before implementing them in a live environment. This is useful for creating blueprint for network expansions, testing new configurations, or experimenting with different network topologies without risking downtime or errors in the live system. For example, a small business planning to upgrade its network can simulate the new setup in Packet Tracer. The engineers would would verify device compatibility, test firewall settings, and simulate traffic loads, ensuring the design works as expected. And next scenario and real-life example would be testing configurations and updates. IT teams in real-life scenarios often need to roll out a new configurations or updates to network devices, and using packet tracers they can simulate these configurations first to observe any potential issues. For example, an organization wants to implement a new VLAN or virtual local area network configuration across multiple switches. The network team can simulate this configuration in packet tracer, testing for connectivity between departments, access controls and security measures to ensure no disruptions occur. And third one is training and skill development. Even professional network engineers use packet tracer to keep their skills sharp and familiarize themselves with new Cisco commands or devices. And this is particularly useful in companies with internal certification programs or ongoing training. For example, an IT team in a company can use packet tracer to practice setting up VPN tunnels between remote offices. They can explore multiple VPN protocols and test for latency, encryption settings and failover options. And next scenario would be in troubleshooting incident response simulation. Also, packet tracer is limited in its simulation accuracy compared to actual network monitoring tools. It can be used to simulate network troubleshooting techniques. This helps engineers prepare for potential incidents by going through mock scenarios. For example, an engineer may simulate network outage by disconnecting certain routers in the packet tracer model. They then use troubleshooting commands like ping or tracer, show IP route to diagnose and solve the problem, training them for similar real-world incidents. And here are advantages of using packet tracer in real life. Cost efficiency. Saves cost of physical equipment for training and testing, as packet tracer is absolutely free. Flexibility. Enables safe experimentation, which can't always be done on live networks. Learning and development. Provides engineers and IT staff a low-risk environment to test skills. Preparation for live changes. Packet tracer helps foresee possible issues before applying configurations in production. And here are the limitations. Despite its strengths, packet tracer has limitations when compared to actual network simulators or production environments. For example, limited realism. Packet tracer may not accurately represent real-life device behavior, particularly under high traffic conditions. Another limitation of packet tracer is protocol support. While it includes major protocols, it lacks some advanced features found in other network simulation softwares like GNS3 or physical devices. And scalability is another limitation of packet tracer. For highly complex networks, packet tracer's resources may be too limited, making it better suited for small to medium-sized simulations. And in conclusion, Cisco Packet Tracer is a versatile, accessible tool, especially valuable in educational and training environments. While it is not typically deployed directly in production environments, it plays a critical role in network planning, training and preparation for real-life applications by providing a safe, cost-effective environment to test configurations and gain practical skills. Packet Tracer bridges the gap between theoretical learning and real-world network management. And today we are going to download and install Packet Tracer on our computer. To do this, go to netcat.com, and netcat.com is official networking academy where you can take lots of free courses from Cisco. You can have a look around, and here at the very bottom of this page you can also see a lots of free courses offered by Cisco. To get a Cisco Packet Tracer we need to take a Cisco Packet Tracer course, and if you want you can take also that course rather than taking my course. And here click on login in the right top corner, scroll down a little bit, and here in the right bottom corner you will see don't have an account, and here click on sign up, and here create your account, submit all information, follow instructions and sign up. Once you have created your account, this is your profile's kind of homepage. If you are not on this page, then click on Cisco Networking Academy logo in the left top corner. On this page you can find more information, and at the bottom of this page you can see all these courses which you can take, and we will be taking this Getting Started with Cisco Packet Tracer. We will not be taking the course, but we will be clicking into it. You can read more information about this course if you are interested. And here on this page we need to click on this button which says Get Started with Self-Paced. Once you click on it, then now we are taking this course. And this is a Cisco Packet Tracer course. I'm going to show you a little bit around, and I'm going to show you how you can find all courses you are enrolled in. Let's close this down, then click on your profile and click on My Learning. And on this page you see all your Cisco enrolled courses. And if you want to go to the main page and find all courses, click on Cisco logo. And here at the very bottom you can find all other courses you can enroll in. And as you can see, they all are free. But we will go to our courses. Again, click on Profile, My Learning. And here click on your course. And now we are on our Cisco Packet Tracer course. Click on your first module and click into very first one, Install Packet Tracer. And on this page scroll down until you will see these two links. And click on second link and we will get redirected to download page. And on this download page scroll down and here you will see these links, and depending on what operating system you are using, select it and download this executable file to your computer. We are using Windows, so click on Windows and download will start. And this is executable file. And once it will be downloaded, go to your downloads directory and click on that file if it's not opening automatically. And if it's opening, then you will see screen like this: Setup Cisco Packet Tracer. To accept agreement and click on Next. Click on Next. Here again, click on Next. Here as well, Next. And on this page, Install. And this window will open, and here you can see also that you have now desktop icon of Cisco Packet Tracer where you can start it, and here click on Finish. And here, would you like a multi-user? Click No. Do you want to allow public and private networks to access this app? Click Allow. On this page you will see two sign-in options. Click on Skills for All. And you will be prompted to sign into your Cisco account. And once you are signed in, you have created an account and you can go and use Cisco Packet Tracer, as now you have installed and set up Cisco Packet Tracer. Before we continue with our Packet Tracer course, I will show you the common issue for new users of Cisco Packet Tracer, as most likely, if you don't know how to resolve it, you will not be able to open your Cisco Packet Tracer. So if you will be opening Cisco Packet Tracer, you will notice that you can't open or you can't log in into Cisco Packet Tracer when you are opening it. You will get to this place once Cisco Packet Tracer will be loaded, and when you will click here on Skills for All, you will not be able to use it or log in. So all you need to do is go to netcad.com, click into your login and log in into your account. I'm logging in into my netcad.com account, and then go back to your Cisco Packet Tracer and open it. So all you need to do every time whenever you are intended to use Cisco Packet Tracer, you need to be logged in into your netcad account. And if I will be clicking now on Skills for All, you will see that I will be logged in into my Cisco Packet Tracer. So in this tutorial we'll explore the Cisco Packet Tracer interface for the first time, breaking down each section of the main user interface or UI to help you become comfortable navigating and using the program. The Cisco Packet Tracer is a powerful network simulation tool used for designing, configuring and troubleshooting network configurations in a virtual environment, and understanding its layout is the first step to mastering it. And now let's overview the main sections in Cisco Packet Tracer. When you open Cisco Packet Tracer, you'll see that interface is organized in several main sections. Here's a guide of each part. Top navigation bar. Located at the top of the screen, this is your main access point for creating and managing files, controlling simulation and configuring the program. File options. Here you can create a new file, open saved files and save your current project. These options work like a typical file menu in most software applications. Then we have view options, options or edit. These menu options allow you to adjust preferences including units of measurement, themes and interface settings. And then you will find help options here. And help options provide access to resources and guides on how to use Packet Tracer's features. And these top bar options are mainly used not in development or creating in Packet Tracer. These are used for saving or opening your files or configuring the look or user interface of Packet Tracer itself or finding help when you need it in help section. And then we have the main workspace or simulation area. This is central largest section of the user interface where you'll actually build and interact with network components. In this space you can drag network devices and connections, arrange them and visually build your network, what we will start doing in next tutorials. And this workspace can be zoomed in or out so you can comfortably view larger or smaller networks as needed. Then we have device selection toolbar. This toolbar is located along the bottom left of the screen and contains icons for different categories of network devices such as routers, switches, hubs and devices like computers or phones and wide area network devices. And you will get comfortable working with these in no time when we will start building networks. Then you have network components. Each device type category such as switches and devices contains subcategories with specific devices that you can use to build your network. If we click here in the first tab on network devices, you can see in second tab appears what network devices we can use. We have routers, switches, hubs, wireless devices, security, wide area network simulations, and we click on next one. Think of this first line as categories and this second line as subcategories. If we click on end devices, and here in end devices we can select different end devices. And once we click on network devices, here you can see routers, switches, hubs and wireless devices, and depending on which one you are selecting, for example, if you would want to select switch, you click on switches, and here in this tab on the right hand side you can see different types of switches which you can use. Or for example, if you click on hubs, here you can see what types of hubs you can use, and this is under these network devices. In this very first tab you can think of it as a main category of devices, and in second tab you can see the subcategory of those devices. And whenever you click on subcategory of the devices, here in the right hand side in this right field you can select what type of device you would like to use. For example, we can click on end devices. We can click on end devices in this subcategory, and then we see here on the right hand side from end devices we have PCs and laptops, servers and many others, and there are many other devices. And here if we click on connections, these would be like wires or your Ethernet cables which you use to connect these devices together. Like I mentioned, you will get familiar with these in no time when we will start building a network. If you just have opened Cisco Packet Tracer for the very first time and you are using it for the very first time, it might look a little bit confusing. And next at the right top corner over the workspace you will notice that there is a logical tab and there is a physical tab. And how they are different is that in logical tab you are seeing the networks which you are building, and in physical tab you are seeing the location where these networks are located. As you can see, here is home city. If we click into it, we can see already corporate office. This means that we have clicked into the city and we are seeing this device in corporate office. If we click now on corporate office, then we are seeing our main wiring closet. And if we will have built some devices, what I will show you also in next video, if you click in that, in this main wiring closet, you will see how these devices physically look. Let's go back to logical, as this is where you will spend most of your time, and this is actually where you will be building and designing your networks. But in short, logical workspace is the default view where you will be do most of your network building and testing. It shows the logical abstract layout of devices and their connections, where physical, like I already mentioned, we can click here on back arrow at the very top. When we click into the physical view, you can see navigation here at the top right. Navigation, this is for physical. If you click in logical, you can see this navigation at the top right for logical view. But let's get into the physical. Physical workspace allows you to view the network physical layout. It is useful if you want to virtualize the actual physical environment like racks in the lab or office space. Switch between these views to get different perspective of your network configuration and layout. And at the bottom of the screen you can see a toolbar managing simulation and real-time modes. As you can see, currently we are in real-time. If we click into simulation, you can see simulation mode. Real-time mode, this mode allows the network to function as if we were operating in real life with instant responses, and any configuration changes take effect immediately. Where simulation mode, this mode slows down the network's operations so you can observe the process and data flow in detail, which is helpful for troubleshooting and learning about protocols. When in simulation mode, you can use play, pause or rewind and fast forward buttons to control the simulation. And this way you will be able to preview how your packages are acting or how your packages are being transferred over the network devices, which will be laid out in your network when you will be performing this or that action. For example, pinging from one device another device, you will be able to see by simulation mode exactly how this package moves from one device to another device and what exactly is happening for this request package from your device to the device which you are trying to ping. And packet flow controls or event list. When in simulation mode, you'll also see the event list on the right side of the screen, which logs each packet movement across the network. The event list provides a step-by-step log of each packet journey, which helps in identifying or confirming that protocols are functioning as expected. You can use the add simple PDU or packet data unit, here as you can see, which is currently located in the middle or right bottom corner, and you can use this PDU or packet data unit tool to send test packets between devices and analyze how the packets are processed. Device configuration panel, and this panel is available when you have already placed some device on the screen. So let's get back into the real-time mode. Here in the left bottom corner, let's click on the end devices. And let's click on PC and then place a mouse cursor somewhere where you would want to locate this PC. If you click somewhere, that PC will be placed. And when you will click on this device which you have placed on this workspace, you will see this device configuration panel. This panel has tabs like config, desktop, programming, attributes, and here in desktop you will be using this the most. For example, if you would want to ping from this PC another device, then you would select this command prompt, and in this command prompt you would be able to use the same commands as you are using in Windows. For example, ping or IP config and others. Let's close this down. Let's click back in desktop. Then here you can also see IP configuration. When you will want to assign a static IP for a particular device or change its subnet mask, you would be able to use this IP configuration. Just double click into it and you can see here that you can allow a DHCP server to assign if you have selected, or set a DHCP server, which we will be also doing in future videos. Or for example, if you want to assign a static IPv4 and you would want to assign your subnet mask to have some devices on the same network. And here is another option under desktop which I wanted to talk about. This is this terminal. This is not a command prompt which we just opened, but this is a terminal, and if you click on the terminal, this is the terminal which you will be using to write the Cisco commands to configure different devices. And to finish this off, you will see here at the top this also toolbar which is used for different purposes. For example, if you click on this zoom, you can zoom in. As you can see, it is zooming in. If you want to zoom out, zoom out. Here is also the selection tool, which you can see in second row, very first tool. This is your selection tool, which you usually use to drag around devices or to drag, for example, highlight network, which you have created, and you can drag it also around. Then you have this delete tool. If you click on that delete tool, if you have selected some device, it will prompt you, do you want to delete? You can delete it. I will not be deleting it just yet, guys. And here is also notes. Notes is also very important, because if you are building a huge networks, or in future when you will have many devices, you will not be able to remember such things as IP addresses, and notes are very good for this, for referencing devices which you are adding on the screen. For example, let's add a note. Just click on it and you can click somewhere to add that note, and here you could write 192.168.1.1. Let's say you added the IP just as a node for this particular device. When I clicked it and I added another node because I am currently in nodes, if I click now on this selection tool, I can drag this node wherever I want to put it. And if I would want to delete, for example, this node, I select this deletion tool and I click on this node. It will prompt me, do you want to delete the selected item? You click on delete and it will delete it. If you would want to delete this device, exactly the same. Once you are in the deletion tool, you click on the device which you would like to delete. That could be device, that could be the wires, that could be the connection between devices, that could be node as you saw earlier on, and you click on delete and it will delete this device. But keep always in this selection, which is very first tool here in this left corner, so you are able to drag things around this screen. So yes guys, this was my quick introduction to what is Cisco Packet Tracer. Hope that you found this useful. We are starting and we will start from building very basic networks, so you get a good feeling how Cisco Packet Tracer works and what you can do here in Cisco Packet Tracer. We are going to continue on in our Cisco Packet Tracer course. We learned what is Cisco Packet Tracer, we went over how to download and install Cisco Packet Tracer, and we went over user interface of Cisco Packet Tracer, and we are going to build the very basic network you can build, and we will be building peer-to-peer network using Cisco Packet Tracer. And peer-to-peer network is a basic connection where two devices like PCs can communicate directly with each other, and we will assign IP addresses and subnet masks and will troubleshoot and will check that this connectivity works. This is the very basic thing what you can build by using Cisco Packet Tracer. This Cisco Packet Tracer tutorial or course is for absolutely beginners, where with each next tutorial we will be building more complex networks and doing also configurations of devices and of these networks. So let's build the network, and to do this, here in the left bottom corner in the first tab you can find devices which you would want to add, and we will be adding or clicking here on this second, which is end devices. And to add the PC, here in this tab to the right you will see all these devices like PCs, laptops, servers, etc. Here click on PC and click somewhere on this workspace, and this PC will be added, and do it one more time by clicking again on PC and clicking somewhere else on workspace where you want to add this PC. Now we need to connect these PCs together, and to do that we need to select connections. If you click on it, here you will see different types of connections which we can use to connect these two PCs together and to connect the same purpose devices. For example, if you are planning to connect two PCs, or if you are planning to connect two switches, in normal scenario you would be using copper crossover cable. But here in Cisco Packet Tracer, if you would be using copper straight through cable, that would also work. But in our scenario, let's do it with copper crossover cable, so you just understand why we are doing it. It is because copper crossover cables are used to connect the same purpose devices, like two PCs or two switches, not like a PC to a switch, but two PCs or the same purpose devices. So click on the PC and here use fast Ethernet 0, and then go to another PC and click on it and also connect it to fast Ethernet 0 port. And now these two PCs are connected. Now that these two devices are connected, you might think that they are already able to communicate with each other. But truth is that they are not, because they are not on the same network and they don't even see each other, because they are connected only with physical cable or physical Ethernet cable, but they are not on the same network. That's why in networking we have networks, and networks also consist of logical connection, which includes IP addresses of devices. For these devices, MAC address is already assigned on their network cards, because network cards or Ethernet adapters are those physical devices which are built into these PCs, which has these RJ45 ports to allow these devices to connect, and they have MAC addresses by default. But devices on network also must have IP addresses and must have subnet masks. If we hover over any of these devices, you will see, like for example for this one, fast Ethernet 0, up there is no set IP address, and we can confirm it by clicking into the device and here go into desktop and here select command prompt and here type in ipconfig. And if we type in ipconfig, you can see that IPv4 address is 00, it's not set, and there is no subnet mask. And exactly the same happens with second device. If we click into it, if we click into desktop, if we click into command prompt, and if we type in ipconfig and we hit enter, you can see that there is also no IP address and there is no mask. And we need to set these up to have these two devices also to be on the same network. By default, in real world scenarios, if these devices would be already connected to some network, then DHCP server, for example a router, would assign IP addresses and subnet masks and gateway address to devices. But in this scenario we have two devices, so there is nothing what could assign IP addresses. In further videos we will create our own DHCP server where I will be explaining you how DHCP server works, and I will demonstrate you how it assigns IP addresses. And now next step, to make a connection between these two devices, we need to add them onto the same network. And to do it, click on one of the PCs. Let's click on this first one, and here in the top you will see this desktop, and where it says IP configuration, click on this one, and here you can configure IP for this particular desktop or this particular device. And as you can see, currently it is set to static, as we will be adding a static IP. If we would select a DHCP, this would mean that DHCP server would automatically add addresses. However, in this network scenario we don't have access to any DHCP. Here in IP address, let's create an address 192.168.1, and let's give it a host .10. And if you will click into subnet mask, a subnet mask will be automatically added to this IP address. So this first device will be with host 10. And now by using ipconfig command we can check whether we have assigned this IP address to this device. And to do this we click again into desktop, or we can close this window down, and here we click into command prompt. And here in command prompt type in ipconfig and hit enter. And here you will see that we have assigned this IPv4 address, which in our scenario is 192.168.10, and subnet mask we have 255.255.255.0. So this device is configured now with static IP address. Now we do have to do exactly the same with another device. So let's click on another device, and here in the top navigation again let's select desktop, and here click into IP configuration, and we will type in IP address 192.168.1 and for host we will give this 20. And also click into subnet mask, and subnet mask for this also will be added automatically. And close this window down, and also let's open a command prompt, and here type in ipconfig and hit enter. And here we can see that this device also we have IPv4 address 192.168.1.20, and subnet mask for this device is also 255, so this means that they are on the same networks. And now to make sure that these two devices are able to communicate, you can use ping command, as ping command is used exactly for this purpose. So let's type in ping, and let's type in the IP address of this first device, as currently you see we are pinging from the device 192.168.1.20. Let's ping address which ends with .10. So 192.168.1.10, and hit enter. And as you can see, this connection is working, as currently this device is replying. We can see that 4 requests were sent and 4 requests were replied. This means that we have successfully created a peer-to-peer network with two PCs, where we have assigned IP addresses to each of them, and we assigned subnet masks so they are on the same network and they are able to communicate. In this tutorial we are going to create a 3PC network using Cisco Packet Tracer. We will connect 3 PCs to a switch, assign IP addresses and verify connectivity using ping command. We will also explore how ARP or Address Resolution Protocol works, examine what happens within a switch when devices communicate, communicate, and we will see how switch learns and stores MAC addresses for efficient data transfer. So let's begin by creating a simple network topology using 3 PCs and a switch. And first thing what we will do is we will add 3 computers or 3 PCs on our workspace. Click here in the bottom left corner on End Devices, and here click on PC. Put your cursor somewhere on screen, add that PC there, and let's do it 2 more times. Now let's add the switch, and to add the switch, also here in the bottom left corner, click on Network Devices and select here in the second navigation or sub-navigation switches. And here we will add the switch. We will be using this switch, which is 2960 switch. By using this switch, we will connect all these 3 devices together. To connect these 3 devices with a switch, we need to use a copper straight-through cable. And to add cables, here in the bottom left corner, again click on this lightning icon, and here you will see this third option, which is copper straight-through cable. Select it, and now let's click on switch, and here in the switch fast Ethernet 01, and then drag it to the very first PC which we have added, which is PC 0, and click on PC 0 and select port fast Ethernet 0. Actually I will add it there, so it is the first PC, this one PC 1 is the second, and PC 2 will be the third PC. And as you can see, when we added this connection, it is still not connected, because normally when you will be in real life connecting switches, they will be establishing this connection until the connection will be established, and in some cases it can take from 1 minute to couple of minutes. And as you can see, now this connection has been established. This course is for absolutely new beginners, that's why I'm going through all these small details. Again, grab copper straight through cable, let's click on switch. Let's use now second port, and let's connect our second PC. And now let's do exactly the same. Again, click on switch, the third port, and let's click on our last PC or third PC which we connected, and click on their Ethernet connection. And here, if you would want to see how it looks in real life, you could click on physical, you click into home city, corporate, and here you can see these 3 PCs, kind of which we have just added, and here is the main wiring closet. If you will click into the main wiring closet, you will see this switch here. Let's go back to the logical area, and now let's assign IP addresses to all these 3 PCs. But before we do that, let's add nodes to all these 3 PCs so we can see what IP addresses we will be assigning to them, because we will be also looking at ARC tables, and it will allow easier to understand which device is which. Here in the top navigation, click here on this node, and let's click this node under this very first PC, which is PC 0. We are not assigning IP address just yet, we are just adding a node 192.168.1, and for this very first PC, host part will be .1. And now, while we are still in this node selection, click to the right of the second PC. This is PC 1 in our scenario. We will be giving IP address to this device 192.168.1.2. So host for this one will be 2. And now let's click to the right of this third PC. IP address 192.168.1.3. And now, once we have added these nodes, don't click anywhere else, but here in the top navigation, click on the very first, which is selection tool. And now let's assign IP addresses to each of these devices. Now we can see them visually, what IP addresses we will be giving them. So let's click on the first PC, and here in the top navigation, click on desktop and click on IP configuration, and this is the place where we will be assigning IP address. So 192.168.1.1, and click into the subnet mask, and subnet mask will be populated. Close down this window. Let's do exactly the same for second desktop IP, and IP for this one is 192.168.1.2. Click into subnet mask, it is populated, and now let's close down this window and let's click in third one, click in desktop, click on IP configuration, and let's assign IP address 192.168.1.3 and click into the subnet mask and close this window. So now we have assigned the IP addresses and we have assigned subnet mask, which means that each PC now has a unique IP address within the same subnet, which allows them to communicate on this network. However, so far we haven't sent any data to any of these PCs. They are just physically connected and they are on the same network, but they still haven't communicated. This means that they still haven't pinged anything, they still haven't sent any files to other PC, they haven't done anything. So all these devices on this network, they still don't know about existence of other devices. For example, PC1 doesn't know that there is PC2 because it has never connected to it. And here comes in ARP, or Address Resolution Protocol, which we will explore how it works. Before we test connectivity, let's explore ARP, Address Resolution Protocol. But let's start by understanding what is ARP. ARP is a protocol used by devices on a local network to find the MAC or Media Access Control addresses associated with an IP address, since data is sent to a specific MAC address on a local network, and ARP helps to resolve the corresponding MAC address for a given IP. So how ARP works? When a PC, let's say PC0, this one, wants to communicate with another PC, let's say PC1, which in our scenario is this one, but PC0 doesn't know the MAC address of PC1, it sends an ARP request. It sends an ARP request to the network, to all this sub-network or all this local area network, asking who has IP address 192.168.12. As we can see, this is this PC. However, PC0 will broadcast this message asking who has 192.168.1.2 to all network. And this in networking is known as ARP request. And PC1, so as PC2, will also get this request. And once the PC1 will get this ARP request, it will respond with an ARP reply that includes its MAC address. And PC0 stores this information in the ARP table for future reference on this PC0. And we can check the ARP tables before and after connectivity. So let's take a look at the ARP tables on each PC before they communicate. So on PC0, click on it, in the top navigation go to desktop and click on command prompt. And here type ARP space dash and A and hit enter. And as you can see, there is no ARP entries found. This means that this PC0 doesn't know about any devices. However, if you would see here in this response a list of IP addresses and MAC addresses, this would mean that this PC1 previously have communicated with any other devices. And you can do exactly the same for other devices. Let's go into PC1, let's click into it, let's click into command prompt, and again type in ARP space dash A, and also no ARP entries found. And the same let's do for the third device. Click on it, desktop, and click into command prompt, again ARP space dash A, enter. No ARP entries. So these devices, all three devices are absolutely new to networks. They have nothing in their ARP tables. But now let's test connectivity, which will generate ARP requests and responses, because we will be testing connectivity from PC0 to PC1. And to do this, click on PC0, here select command prompt and ping this PC1, which IP address is 192.168.1.2. So type in ping space and IP address and hit enter. And as you can see, there were requests which all were replied. This means that PC0 sent an ARP request to all network. It broadcasted message. This message was received by PC1 and PC2, and PC1 checked this message and it saw that its IP is being requested, and it replied with its MAC address and with its IP address. And when PC0 got this information, it stored this information in its ARP table. And we can also check it by again typing in ARP space dash A and hit again enter. And now you can see that now in the ARP table there is internet address. As you can see, it has been stored at 192.168.1.2. It has been stored in the ARP table of PC0, and also physical address, and this is the physical address, which is MAC address for also this PC1 with IP address 192.168.1.2, as you can see here. And it says that type is dynamic. This means that this address has a time limitation, that it can expire if these two devices will not be communicating for the longer time periods, where there is also a static type. Static type means that the IP to MAC address mapping has been manually configured and do not expire or be automatically removed. So as if you would want also, you could remove this mapping record from this PC's ARP table. And to do that, write the command ARP space dash and D and hit enter. And to check if this ARP table is empty, again type ARP space dash and A and hit enter. And now you can see that there is no ARP entries found in this table. So to remove it is ARP dash D, and to check your ARP table for your PC, even your home PC, you are typing ARP space dash and A. And now again let's type a command ping, and let's ping again. And to not type this command, you can use arrows up and arrows down on your keyboard. If you didn't know that you can do it. To type this again, let's ping again 192.168.1.2, hit enter, hit enter, and you can see that this request again is being sent, and the request was sent and it has been replied. And now again to check your ARP table, type in ARP space dash A and hit enter, and again that record is there. So this is how ARP works. I'm just trying to explain this for absolutely beginners, so as if you are following my tutorials, make sure that you are exercising and doing exactly the same, so you are getting the real feel, not only watching these videos. Now let's go over one more time what happens when PC0 will send a ping to PC1, or will ping the PC1 IP address 192.168.1.2. First, PC0 will check its ARP table for the MAC address of 192.168.1.2. Since it will not be there until the PC0 will ping it, PC0 will broadcast an ARP request to the network, and PC1 will respond with an ARP reply containing its MAC address, which PC0 will add to its ARP table. And only after the ARP exchange, the ping will proceed, and you should see responses in the command prompt indicating successful connectivity, which we saw there. And similar way you can play around with all other devices. But now let's discuss how switch learns and uses MAC addresses to optimize the data flow. So learning phase in switch, when PC0 sends the ARP request, it sends it as a broadcast and the switch receives it on the port where PC1 is connected. And switch learns the MAC address of PC0 is associated with fast Ethernet 01. And to build the MAC table, the switch creates table mapping MAC address to switch ports, and this table is known as MAC address table, or CAM, content addressable memory table. And how switch makes forwarding decisions: when PC1 responds to the PC0 ARP request, the switch also learns PC's 1 MAC address and associates it with fast Ethernet 02, where we connected it to the switch, and future packets from PC0 to PC1 will be directed specifically to PC's 1 port, reducing unnecessary broadcasting. So this all is being done to not have this unnecessary broadcasting, as switch knows that now PC0 is in this port, and switch also knows that PC1 is also this port. And whenever PC1 will want to connect to PC2, switch now knows on which port these two PCs live, so it will be directly directing traffic from PC0 to PC1 or from PC1 to PC2 without broadcasting, because broadcasting is not necessary anymore, as switch now knows that these ports are associated with these MAC addresses. And as a result, here you understand that switch is transferring data between connected devices based on their MAC addresses, which it learns and which it stores in its MAC address table. And here is how you can view the MAC address table on switch in Cisco Packet Tracer. Click on the switch, then click here at the top navigation in CLI, and this command line interface will open up. Press enter, and once you will press enter, you will see this switch. And here let's type in a command: show space MAC space address dash table, and hit enter. And here you can see that this table is currently empty, which means that this switch haven't learned any MAC addresses. So let's close this, click on PC0, click on command prompt, and here again let's ping device which IP ends with 2, and hit enter. So we pinged this device. Now let's close this window, let's click on switch, let's go into CLI, and on switch again Let's type the same command, show MAC address table, and hit enter. And now you can see that VLAN or virtual local area network, here is the MAC address of one device, and the type for this MAC address is dynamic, and it has assigned it to port 1, or it knows that this MAC address device, this particular device, is connected to port 1, and the device with this MAC address is connected to port 2. And now if you would want to check it also with the third device, let's close this window down, and now from PC0 let's ping the IP address of our third device. Let's click on PC0, let's click on command prompt. Here we will ping the IP address 192.168.1.3. Hit enter. As you can see, pinging is happening. Straight away you can check ARP, whether it added it to the ARP table. Type in ARP space -A. Hit enter. You can see that now in PC0, in our PC0 ARP table, there are two IP addresses stored, and there are also two MAC addresses stored for those devices, and they both types are dynamic. So let's close this down. Let's click on switch, and again go into CLI, and again type in show MAC address table and hit enter. And now you can see the MAC addresses for all our three devices, and you can see where are ports that these devices have been assigned to these ports. Now you understand what is ARP, what is MAC table, how ARP works, and how switch is creating a MAC address table, and how switch is assigning these MAC addresses to its ports. We are going to build another network. We are going to build a network like this. We are going to build this virtual local area network. And for those who doesn't know what's the difference between local area network and virtual local area network, the only difference is that one big local area network, for example, imagine your school, or for example one big office building where are lots of computers, let's say 100 or 200 or 300 computers. You are spreading these computers into smaller networks, smaller local area networks. But at the very beginning, this whole building with all these 500 or 300 computers, depending on how big is the organization, this could be considered as one big local area network. But in real life we are creating virtual local area networks, and the main purpose is to separate these devices into smaller networks. For example, this local area network on the right could be for one classroom, this local area network could be for another classroom, and there might be other small local area networks. But as we are spreading out or separating one big local area network for that organization, which belongs to that organization, into these smaller local area networks. All this together is called virtual local area network. And in this tutorial we will be building the simplest virtual local area network, where we will use only one router, which you can see here in the middle. And this one router will be separating local area network into smaller local area networks, and this will make this one big local area network to virtual local area network. So on the left hand side we will have one local area network where we will have a switch, where we will have 3 computers, and we will also add a wireless access point, so mobile device or mobile devices can also connect to this local area network. And on the left hand side we will also add a switch to the same router, and we will add to this switch 3 computers. So no further ado, let's get into it and let's build this network. And we will start by adding devices to our workspace. And let's start by network devices. Click on network devices, and here at the bottom make sure that you are in routers. Click into the routers and select router 1941 and put it in the middle of this workspace. And let's click again onto the network devices and click on switches in the second tab, and let's select this switch 2960 and let's put it on one side of this router, and let's select another 2960 and let's put it to the other side of this router. And now we need end devices. Click here in the first tab, end devices, and here select PC and place one PC, and similar way place another, and similar way another PC. On the right hand side we will also add 3 PCs. And now we will add access point here near this switch, because we will be connecting access point to this switch, so it is in the same local area network. To add the access point, we also need to go into network devices, select wireless devices in the second tab, and here select this WRT300N and place it somewhere here, and this is wireless access point. And now let's connect all these devices, and to do that click in the left bottom corner on connections and click on copper straight through cable. Let's start with switch. Let's click on switch. Let's add Ethernet 1. And Ethernet 1 we will connect to our first PC. Do exactly the same. Click on copper straight through cable. Again click on switch. Click on Fast Ethernet 02 and click on this PC 1 and click Fast Ethernet, and the same for third one. Click on switch, click on Fast Ethernet 3, click on this one, and now let's do exactly the same. Let's click on this copper straight through cable, let's click on switch. Let's add it to port 4 and let's click on this wireless access point. As you know, wireless access points are also connected by physical cables. Now let's do exactly the same on this other network. Let's click on copper straight through cable, click on this switch, Fast Ethernet 1. Let's click on this first device, Fast Ethernet 0, and let's add also both of these other devices to this switch and device, and let's add it. And now let's connect these switches to this router, and now let's connect this router to the first switch. So let's use for first network gigabit Ethernet 00, and let's connect it also to gigabit Ethernet 01 on switch. And let's connect exactly the same way the second switch to the router. Also let's take copper straight through cable, let's click on router gigabit Ethernet 01, and let's click on switch and let's connect it also to gigabit Ethernet 01. As you can see, there is no connection established between switches and between routers. And why it is, I will tell you a little bit later. But before we continue, let's add also this wireless device. So click here on End Devices in the left bottom corner, and here on the right, let's select Smartphone. If you scroll a little bit to the right, and here you will see this fourth option from the right hand side, smartphone. Click on smartphone and add it here somewhere above access point. Also established connection between the access point and between this smartphone. And now before we continue, let's configure IP addresses and subnet masks for all of these devices on this network. But before we do it, I will add nodes of IP addresses which I will be assigning to all of these devices, so we can visually see which device is which and what IP address it has. So to add nodes, click here on nodes at the very top, and here for this smartphone we will add IP address 192.168.1.5. Then click under the first PC, which is PC0 in our case, and let's add IP address 192.168.1.2, and then click under the second, which is PC1. Again, let's add node 192.168.1.3, and let's click under the fourth device or the third PC, which is PC2 in our scenario, and let's add a note that this device's IP address will be 192.168.1.4. Now we also need to add an IP address at the router, and router will have two IP addresses, and router's IP address will be 192.168.1.1. And now let's add IP addresses for all these devices. The IP address 192.168.2.2. PC4 will be IP address 192.168.2.3, and PC5 will be 192.168.2.4. And the router's IP address here for this other network, which is on the right hand side, we will have IP address of 192.168.2.1. And now once we have added these labels or these nodes for all these devices, we need to do actual configuration of these IP addresses for all of these devices and add subnet masks. Let's start with smartphone. Let's click on smartphone. And let's click into the desktop and let's click IP configuration, and here we also will be adding this IP address, and here we click on static, and here where it says IP address, let's add this IP address, which is 192.168.1.5, and if we click on subnet mask, it will be populated automatically, and close this. And now let's do exactly the same for this PC. with 0, which is PC1 in this network. Let's click on it. Let's click on desktop. Let's click IP configuration and let's here add 192.168.1.2 and let's click into subnet mask, and subnet mask will be automatically populated. I will actually copy this IP address so it's easier to add for other two devices. Let's close this down. Let's click on this second PC, which is PC1. Let's click on desktop. Let's click IP configuration. Let's paste it here and let's change 2 to 3 and let's click into subnet mask, and subnet mask is populated. And now let's click into this third PC, which is PC2. Let's click on desktop, IP configuration, and here we also paste in, and here we change 2 to 4. So IP address is 192.168.1.4 and click into subnet mask, and subnet mask will be populated. And let's close this down. So this network on the left hand side is now assigned with IP addresses and subnet masks, and similar way let's do with devices on the right hand side. So let's click on PC3, let's click into the desktop, IP configuration, and let's add IP address of 192.168.2.2, and I will also copy this so it's easier to add to other devices, and subnet mask populated automatically. Let's close this down. Let's click on second device, and here we also click on desktop, click on IP configuration. Let's add IP address, which will be 192.168.2.3. Let's click into subnet mask so it is also populated, and let's click into this last third device. Click in desktop, IP configuration, and let's add its IP address, which is 192.168.2.4. And let's click into the subnet mask. So subnet masks and IP addresses are now added to all of these devices. But here we also need to configure IP address for this router. So let's click into the router. Let's click into the config. Here in config, in configuration, in future videos I will show you how to configure these IP addresses on router using CLI, but as these are only starting tutorials, guys, I am going to show you how to do it with this user interface or UI, as here I am trying to explain you or want you to understand what is really happening behind the scenes and how this network works. So here, as you remember, we connected this one switch from this network, which is to the left hand side, to the port gigabit Ethernet 00. So we need to add this IP address 192.168.1.1. As you can see, this is one network, as it is 168.1, and this network which is on the right hand side, this is already with IP address 192.168.2, not 1. So these are two different networks. And here on gigabit Ethernet 00, let's click into it, and here we need to add IP address, and here we need to enable firstly this port. As you can see, port status, currently it is off. If we check mark this very first field, it will enable it. And here, as you can see, IP configuration, here IP4 address, this is where we are adding this IP address, which is 192.168.1.1. and here's the same for this router on the gigabit Ethernet 2. We connected this other switch. Let's click into it, and here we also port status is currently not on, but if we need to check mark, so this is on. And here also IP configuration, we need to add this other IP address, which is 192.168.2.1, and then we can close it down. And now, as you can see, as we added these IP addresses to router, it physically connected these two networks. However, these two networks are still not connected and they still don't see each other. And as a proof, I will click on this very first device, which is PC0 in our case. Let's click into it. As from previous videos, you already know how to check the network connectivity with other devices. And now let's open a command prompt, and in command prompt let's try to ping, for example, this phone, which IP address is 192.168.1.5. ping 192.168.1.5 and hit enter. And here you can see that we are able to ping this phone because it is on the same network. So as we will be able to ping any other devices which are connected to this switch and which are on this side of this router. But if we from this will try to ping, for example, this device which is PC3, let's see what will happen. So let's type in ping 192.168.2 and .2 and hit enter. And you will see that it is not able to ping it. Request timed out. Let's close this down. And now for those who doesn't know why this network is still not able to ping this network, the reason is that if you are on local area network or devices are on one local area network, they can communicate with each other if they are on the same subnet and they are assigned with the same IP range. But if they want to connect to another network, networks are being connected by using routers and IP addresses. As you can see here, we are using router to connect to networks. And the networks are being connected based on IP addresses of these networks. As you can see, we are connecting this network which is on the left hand side, which IP address is 192.168.1.1, with network which is on the right hand side, which IP address is 192.168.2.1. But they are not able to connect because when you are connecting from any of these devices, then this is a gateway address. In this scenario, our gateway address which should be assigned to these devices is 192.168.1.1. So let's check whether this phone has a gateway of 192.168.1.1. As these devices on this side, if they want to connect to another network through router, they need to communicate to the router. And all devices on some particular network, they are communicating with router with gateway address, or they must have assigned gateway address. So let's click again on the smartphone. Let's click into IP configuration and let's have a look at what gateway it has. As you can see, currently it's default gateway which has been assigned automatically when it was using DHCP is 192.168.0.1. So it is not connecting or not communicating to this router. So we need to change this default gateway address so this mobile device is able to reach out through this router to the other network by using router's IP address, which is 192.168.1.1. So it should end not with .0.1 but with .1.1. And let's close this down. And now let's again click on this mobile phone. Let's click on command prompt, and from this mobile phone again let's try to ping this other device which is 192.168.2.2. So let's type in ping 192.168.2.2 and hit enter. As you can see, pinging is still not taking place, and this is probably because of the reason that this device with IP address .2.2 it also doesn't have a gateway assigned of this router. So is from this side it has to be exactly the same. This device, which is PC3 in our scenario, it should have a gateway address of this router which is 192.168.2.1. So let's click on this device, let's click on IP configuration, and here we can see that here default gateway is 4 zeros, so let's delete it, and also let's assign 192.168.2.1 and let's close this down. And now let's click again on this mobile phone, let's click in command prompt, let's again ping this device with IP address 192.168.2.2 and let's hit enter. And now you can see that these two devices are able to communicate. However, if we will try to ping from this smartphone, for example, or from any other of these devices, the device with IP 192.168.2.3, let's do it. Let's ping .2.3. You will see that they will not be able to communicate. As you can see, pinging, it is trying to ping, but it is not able to ping. So here you understand one important thing, that all devices which are on some particular network, for example on this side, they have to have a gateway address of this router to be able to communicate to any other network which is outside this particular local area network. Meanwhile, they can communicate to each other, but they can't communicate outside if they don't have a gateway address. So now let's configure gateway addresses for all of these devices. Let's open this PC 0, which in our case is our first PC. Let's click on IP configuration, and here also let's add default gateway address, which is 192.168.1.1, which is this router's IP address. As you can see, in any network which is local area network, if you want to communicate outside that particular network, they have all the same gateway, default gateway address. So I will copy it, I will close this down, I will open this next device, click on IP configuration, and also will assign 192.168.1.1, close this down, and our fourth device or third PC, and click on IP configuration, and also will assign this default gateway, and close this down. And now these four devices, they are able to reach out, but they are still able to reach out only to this device. And we can check it by clicking on this second PC, which is in our scenario third computer, PC2, and click on command prompt, and here we type in ping, and let's ping this very first device, which is at the very top, which is 192.168.2.2, 192.168.2.2, and let's hit enter. And as you can see, pinging is happening. This means that this PC2, it is able to communicate with this PC3 on this other network. But if we will try to ping from this PC2 again PC4, you will see that nothing will happen with IP address, which is 192.168.2.3. Hit enter, and here you can see that request timed out, and we are not able to communicate not to this device or not to this device. And the reason is exactly the same, because we assigned gateway address to this PC3, but we didn't do it for this PC4, and we didn't do it for this PC5. So let's click on PC4, let's click into IP configuration, and also let's assign this IP address, which is 192.168.2.1, and I will copy this IP address, I will close this down, and I will click on the last PC, IP configuration, and also the same gateway. Let's add it there, guys, and let's close this down. Now again, let's click on PC2, and let's try to do the same pinging of these two devices. Let's open command prompt. Now let's start with 192.168.2.3, which is this PC in our scenario, and hit enter. And now you can see that we are able to ping or communicate with this device. And now let's do exactly the same for device 192.168.2.4. And let's click enter, and here you go, guys. We are able also to communicate with this device. So now we have built a network with one router, with two switches, with one wireless access point, and with one wireless device, which is smartphone, and three computers on one side and three computers on the other side, and they are able to communicate to each other, and we did some troubleshooting. I tried to demonstrate you the very basic virtual local area network and how it works, and why we are having gateway addresses, and why we have IP addresses, and why we need each network to be separated into different networks. And routers also usually have two IP addresses, which are usually gateway addresses from one side. That could be like ISP or internet service provider, if that would be internet, which we will be looking in further videos when we will be discussing NAT tables. But in local area networks, those are usually private addresses which are connected from both sides of the router, as you can see here in our scenario. Today we will be doing Cisco Packet Tracer step-by-step switch configuration, and in this tutorial we will configure a Cisco switch in Cisco Packet Tracer to build a basic local area network or LAN. We will create a network with multiple PCs connected through a switch and configure VLANs or virtual local area networks to segment the network traffic. And this setup is useful for understanding how to manage switch configurations, ensure proper communication, and enhance network security. We will start by network design, and in this network design we will have one Cisco switch. We will be using Cisco switch 2960. This is layer 2 Cisco switch. We will add 4 PCs connected to the switch using straight through Ethernet cables, and we will create 2 VLANs or virtual local area networks, where one will be VLAN 10 .10 for PCs in group 1 and VLAN 20 for PCs in our second group or group 2. We will assign IP addresses to the PCs. We will configure switch, and in our switch configuration we will set a hostname for the switch. We will assign ports to virtual local area networks. Remember, we are creating two groups of PCs, where in each group will be two PCs, and we will assign ports on the same switch for these groups of PCs. And we will enable inter-PC communication within the same virtual local area network, and then we will verify connectivity using pin command. So let's get into it, and first let's add the devices, and let's start by network devices. Click on network devices at the left bottom corner, and here in the next field select switches. Find the very first switch, which will be 2960. Click on it and click somewhere on workspace where you would want to place this switch. And now let's add 4 PCs or computers, and to do that, in the very first field in the left bottom corner click on end devices, and here to the right select PC. And let's add 4 PCs. Select PC again, add another PC and another 2 PCs. Then to connect devices in the left bottom corner select connections, and here to the right select copper straight through cable. First we will click on the switch, select fast Ethernet 01, and then we will click on our first PC, which is PC 0 in our scenario, and let's add it to fast Ethernet 0. Let's do exactly the same with all other devices. Copper straight through cable, click on switch, fast Ethernet 2, let's click on our second PC, copper straight through cable, let's click on switch, let's add it to fast Ethernet 03, and let's add it to the third, this is PC 2 in our scenario, and click on fast Ethernet 0. And let's add our last device, click on copper straight through cable, click on switch and fast Ethernet 04, and let's click on our fourth device and let's connect it to fast Ethernet 0. And in the next step we need to assign IP addresses to our PCs. Let's start by adding nodes to each of these PCs so we know what IP addresses we are assigning them. So in future when we are working with any networks, by adding these nodes, as you can see here in the top second or third navigation, if you click on place node, you will be able to place node under each of these PCs. So it will allow us easier to understand which PC is which. So let's click under this first PC, which in our scenario is PC 0, and we will be assigning IP address 192.168.1.10.2. Now click on our PC1, or which is PC2 in our scenario, and let's assign IP address 192.168.10.3. And we will also be assigning IP addresses to PCs which are on the right hand side. However, these PCs which are on the right hand side, they will be on different network, and that we will be configuring in our switch. So let's assign the IP address of our PC2, or which will be on another network. This will be in network 20. So let's click under PC2 and let's add the node that we will be assigning to this PC IP address of 192.168.20.2. As you can notice, on the left hand side to these two PCs we assigned the IP address with .10, but on the right hand side we are assigning IP addresses with .20. This means that these 4 devices will be on 2 networks, where in each network we will have 2 PCs. One will be in IP of range with .10, and devices on the right hand side will be in IP range with .20. So let's add another node under PC3, 192.168.20.3. Now let's assign these IP addresses. Hover in the right top corner back to this selection tool, and now click on this for our first PC, which is PC 0 in our scenario. Here select desktop and click into IP configuration. Here make sure that static is selected, and in very first field IPv4 address, let's assign IP address 192.168.10.2. Click into subnet mask field and it will get populated automatically. Let's do exactly the same for all other devices. Let's click on PC2 in our scenario, which is PC1, and click on desktop, IP configuration 192.168.10 and .3, and click into a subnet mask field and close this. And now let's click on this side of these devices. Here we also select desktop, click in IP configuration, and here we type in 192.168.20.2 and click in subnet mask, close this field. Let's click on our fourth device. Let's click in desktop, IP configuration 192.168.20.3 and click into subnet mask and close this window. So now we have assigned all IP addresses to all our devices, and as these devices on the left hand side are on network .10 and these devices on the right hand side are on network .20, we need to configure our switch. And to do that, let's click on the switch. Here select CLI or command line interface and hit enter. And once you will hit enter, you will see switch. First thing what we will need to do is to enter a global configuration mode, and to enter a global configuration mode we need to type in enable. Hit enter and type in configure terminal and hit enter. Sorry, I made a mistake. Configure terminal and hit enter. And first thing what we will be doing now is we will be setting the switch host name, and we will call this switch simply my switch. And to do that, type in hostname space, and you can choose any name for your switch host name. Like I mentioned, I will be typing in simply my switch and hit enter. And as you can see now, it is my switch and we are in configuration. What we will be doing, we will be creating these VLANs. As you remember, we had this VLAN or virtual local area network, one with .10 and another one is with .20, as you can see here on the right hand side. These two devices are with .20 and these two devices on the left hand side, they are with .10. So we need to configure the switch and create these two VLANs. And to do that, here in CLI type in space 10 and hit enter, and we will give a name of group 1. Type in name and type in group 1 and hit enter. Type in exit and hit enter again. And now we have to do exactly the same for our other VLAN. So type in VLAN space 20, hit enter, type in name space group 2, hit enter and type exit and hit enter. And now we have created a VLAN 10 and we have created a VLAN 20. And once we have created these two VLANs with these two groups, group 1 and group 2, we need to assign a ports to these VLANs, where we will be assigning fast Ethernet 01 and fast Ethernet 02 ports to VLAN 10. This will be for these two devices, and we will be assigning fast Ethernet 03 and 04. As you remember, we connected these two devices on the right hand side to ports fast Ethernet 03 and 04. And let's continue by typing in interface space fast Ethernet 0/1 and hit enter. And now type in switch port mode access and hit enter. And now type in switch port access VLAN 10, hit enter and type in exit and enter. And this way we have assigned fast Ethernet 01 port to our VLAN 10. And now we have to do exactly the same with all other three ports, as there are two ports for VLAN 10 and two ports for VLAN 20. So let's do exactly the same for our fast Ethernet 02. I will just click arrow up, so I return back to interface fast Ethernet 01 and I will change 1 to 2 and hit enter. And then again by clicking on arrows up, let's return back to command switch port mode access and hit enter, and again hit arrow up on your keyboard until you will get to switch port access VLAN 10 and hit enter. Here again arrow down until you will get to exit and hit enter. And exactly the same needs to be done with fast Ethernet ports 03 and 04. Only those we need to assign to switch port access VLAN 20 rather than 10. So let's do exactly the same. After you have done exit, let's type in interface fast Ethernet 03. Here we change to 3, hit enter. Here switch port mode access, hit enter. Here switch port access VLAN 20. Not 10 but 20, hit enter and exit and hit enter. And again we need to assign fast Ethernet 04. Here we change 3 to 4, hit enter, go to switch port mode access, hit enter, again arrow down until you will get to switch port access VLAN 20, hit enter, and exit and hit enter. And now we have assigned all these 4 ports. First 2 ports on the switch for fast Ethernet 01 and fast Ethernet 02 we have assigned to VLAN 10. And fast Ethernet ports 03 and fast Ethernet 04 ports, which are on the switch, we have assigned to VLAN 20, which are for our devices on the right hand side of this switch. And last thing what we need to do is to save this configuration and type in here right space memory and hit enter. So type exit again as we got this error and type again activate memory and OK. And close this down. Let's open a command line on our first PC which we added, which is PC0. Let's click onto the command prompt and let's try to ping this our first computer. So type in ping 192.168.10.3 and hit enter. And as you can see, pinging is taking place. This means that they are on the same network and these 2 devices are able to communicate. And now from the same device, which is in 192.168.10.2, let's try to ping any of these devices which are on the right hand side. And this communication should fail because these devices are on different VLANs. As you can see here, they are on different VLANs, one is .10, one is .20, and they theoretically can't communicate to each other without a router. So let's try to ping from 192.168.10.2, let's try to ping this device which is 192.168.20.2. Let's type in 192.168.20.2 and hit enter. And as you can see, pinging 192 with the bytes are of data. Currently it's trying to ping, but it is not able to ping. This means that what we have done here is we have created 2 networks. We assigned ports to each of these networks. We created a group that this is group 1 on the left hand side and this is the group 2. We gave a name to our switch, and on this switch we separated local area network into 2 networks which are not able to communicate with each other. In this tutorial I just wanted to show you how you can separate networks, how you can create a virtual local area network from a local area network, and how you can divide a network and how you can assign ports on switch. And in this tutorial we are going to learn how to configure IP addresses in Cisco Packet Tracer using CLI or command line interface commands on a router, and assign IP addresses to 2 PCs and a mobile device connected via switch. So in our network topology we will have 1 router, we will have 1 switch, and we will have 2 PCs and 1 mobile device. And the main takeaway which you should take away from this tutorial is how to configure IP address in router in command line. So let's start by adding our devices to our workspace, and let's start by adding a router. Click into the network devices, and in second device navigation in the left bottom corner make sure that you are in routers, and we will be using router 1941, which is the 3rd router here. Click on it and click somewhere on workspace, and this router will be added. Next we need to select a switch. Click in the left bottom corner on switches, and we will be using switch 2960 and click somewhere on workspace. And then we will be adding 3 end devices where we will be adding 2 PCs. So let's click on end devices in the left bottom corner, and let's select very first one here to the right, which is PC, and let's click it somewhere on the screen. And this will be PC0. Then click again on PC. Let's add another PC. This will be PC1. And here at the end devices you will find also a smartphone. So click on it and add it also on workspace. And now we need to connect all these devices. Let's click here in connections in the left bottom corner, and let's use a copper straight through cable. If we click on routers, then here you will see that gigabit Ethernet 0/0. Make sure that you remember this port, as we will be needing, or we will be configuring this port gigabit Ethernet 0/0 to add IP address to this port when we will be doing configuration by using CLI. So gigabit Ethernet 0/0, click on it and click on, and here we will add it to fast Ethernet 0/1. And now let's connect both PCs the same way by using copper straight through cable. So let's click on it, then let's click on switch. let's use fast Ethernet 0/2, then click on first computer and let's connect it to fast Ethernet 0, and let's do exactly the same with our last computer. Let's click on switch, fast Ethernet 0/3, let's click on computer and fast Ethernet 0. Let's start by configuring our router, and to configure router, click on your router. Here click into CLI. Here, as you can see, would you like to enter the initial configuration dialog? You say no, hit enter, then click enter again, and then you will access this router. As you can see, now we are in router, and to enable this router or to enter privileged exec mode, we type in enable and hit enter, and you will enter this router mode. And now we need to enter global configuration mode, and to enter a global configuration mode, we need to type in next command, which is configure terminal, and hit enter. And this global configuration mode, which we just entered by entering command configure terminal, this mode allows us to configure various aspects of the router. And first aspect which we will be configuring, or which we want to configure on this router, is this port which I was mentioning earlier on. If we hover over router, as you can see, there is gigabit Ethernet 0/0 port. So to configure this port, which is also called in Cisco Packet Tracer or in Cisco in general interface, we need to type in a next command. And next command is interface space, and we need to type in the name gigabit Ethernet 0/0, as we want to configure this interface, like I mentioned, interface or this port, which is called gigabit Ethernet 0/0, and hit enter. Once we have entered this interface configuration, as you see here, we typed in interface, then we wanted to configure this interface gigabit Ethernet 0/0. We will assign IP address to this interface or to this port on our router. And to assign IP address to our port, we need to type in next command, which is IP, as we want to assign IP address, and then we need to specify IP address. In our scenario, that will be 192.168.1.1 space, and after space we need to also specify a subnet mask, and subnet mask will be 255.255.255.0, and hit enter. And here we assign the IP address 192.168.1.1 with a subnet mask of 255.255.255.0, and this will serve as a gateway for the connected devices. So this IP address will be also the gateway for all those devices which we added, which is 2 PCs and 1 smartphone. And there is one more command which we need to type, and it is no space shutdown. This command activates the interface, making it operational. This means that we enabled, as you can see, now we enabled this port or this interface on our router, and it became green, and now it is connecting or establishing connection between the router and our switch. And now we need to type exit and hit enter. Again exit, as I was not in the command, and hit enter. And we needed to type this exit command, as this exit command means that we have completed the router's interface configuration and we exited this configuration mode. And now we can close this CLI or command line interface, as now, as you can see, we have configured our router. And let's add a note under the router with the IP address we have given it, which was 192.168.1.1. So now we can visually see the IP address which we have given to our router. And always router's IP address is the gateway address for all our devices. Now let's assign IP addresses to all our other devices. Let's start with our first PC, which is PC0. Let's click on it and select here in the very first tab, desktop, and click on IP configuration. Make sure that it is set to static, and let's type in IP address 192.168.1.2 and click into subnet mask field, and it will get populated automatically. I will copy this IP address, close this down, click on our second PC, which is PC1. Let's click into desktop, Click on IP configuration, very first one. Make sure it is in static. I will paste that IP, and here I will change the very last part. So our IP address for this device is 192.168.1.3. Click into subnet mask field, it will get populated, and let's close this down, and let's do exactly the same with our smartphone. Go into desktop, IP configuration, static, and here also we will type in IP address, but we will end it with 1.4. And actually one more thing which I forget to do. Let's click into subnet mask, and which we need to do for all these three devices. And those who understand what we are doing here is very important, default gateway. And default gateway, like I mentioned, is usually your router's IP address, which is 192.168.1.1. This means that in default gateway we also need to enter 192.168.1.1. And I will copy this, close this down, and I will click on our first PC, again IP configuration and default gateway also 192.168.1.1, and let's do exactly the same for our last PC, also default gateway 192.168.1.1, which is our router's IP address, and close this down. And here you will notice that our network is not connected, or our smartphone is not connected to anything, and the reason here is because of our router. And here I wanted to highlight or made this mistake deliberately, so you understand that router's main purpose is to route traffic between networks, not to provide Wi-Fi connection. However, at your home routers you will find also that access point is built into it. And here, to solve this problem, we will need to create a wireless access point so our mobile can also connect to our network which we have created. We also will need to create it, so click on network devices. Here in the left bottom corner select wireless devices, and here select VRT300N router, or this will act as wireless access point in our scenario. Then we need to establish connection, so in the left bottom corner click on connections, and then select copper straight through cable, and then click on switch, and we will attach it to fast Ethernet 04 port, and then click on this wireless access point and connect it to internet, and then click on this wireless access point, as we also need to configure IP address for this wireless access point or this wireless router. So click here into configure, and here click into internet, and here we need to select static, as we want to add a static IP address, and our IP address range was 192.168.1.5, as this will be the fifth device in our network. And click into the subnet mask field, it will get populated automatically, and as default gateway we also need to give it a router's gateway, which is 192.168.1.1. So let's do it, 192.168.1.1, and here we can close it down. And now you can see that this also have a wireless connection to our smartphone. But for example, if you on your wireless router you would want to restrict this smartphone or allow this connection only by using some password, I will also show you how you can do it. So let's click again on this wireless access point. I will be calling this wireless access point router. Let's click on it, and once this opens up, here you will see tab wireless, and currently you can see authentication is disabled, but here we can enable authentication by clicking into WPA2-PSK, this one, and here we select the password which we would want to add to our network for devices who would want to connect wirelessly to this access point. So here I will type in 1 2 3 4 5 6 7 8. You can type there whatever passphrase or password you would like to give, and let's close this down. And now you can see that this smartphone is not able to connect this wireless point, because this is like in real world scenario. For example, if you would want to connect to some network network, you would need to provide a password. And we need to configure this also on our smartphone. So imagine that the network administrator or company, they gave a password to the smartphone user, so the smartphone user can connect to this network. So let's click onto this network, and here let's also select wireless 0, and here we also select VPA or WPA2-PSK. Let's click in there, and then on the smartphone we will add the same password, which in our scenario was 1234567 and close this down, and now this connection should establish again. Let's open again. Wireless. Actually I made a mistake. As you see, 1234, I added 2 4s, that's why it didn't connect it. 1234567 so it is the same password. So let's close this down, and now you can see that this connection has established. And here you will notice one thing. If we will try to ping from our PC1, let's open up and let's open a command prompt. If we will try to ping here from this PC0, we will be able to ping it. Its IP address was 192.168.1.2 and hit enter. As you can see, pinging is taking place. However, if we will try to ping now this smartphone which we added to this wireless router, you will see that we will not be able to ping it. So let's try to do it. So let's ping 192.168.1.4. As you remember, our IP address for our smartphone is 192.168.1.4. Let's hit enter. You will see that pinging is not taking place. And this is because of reasons that some wireless routers have built-in function which is called wireless isolation, which prevents wireless devices from communicating with other devices on the same network. And this is the case with this router which we added here, as this router is preventing this wireless device to communicate with other devices on the same network. And like I mentioned, and this is called wireless isolation, and in some routers you can disable that functionality. And the very last thing what I wanted to show you here is on this router how you can check router interface status. So let's click on this router, let's open a CLI and hit enter. And to check router's interface status, let's type in a command show space IP space interface, and as you know, interface are those ports on the router, space and brief, and hit enter. And here you can see what is happening on our router. As you can see, it is connected, or our router is using port or using gigabit Ethernet 0/0 port. As you can see here, this router is using that port, and it is connecting, or a gateway or IP address for that port is 192.168.1.1, which we set up, and status is up. This means that it is working and it is functioning. And by using this command show IP interface brief, this command displays a summary of all the router's interfaces, their IPs and operational status. For example, if you would want to just to check how many ports this particular router have, so here you can see that this particular router has 2 ports, gigabit Ethernet 0/0 and gigabit Ethernet 0/1, and only one port is used, which we use to connect all this network to this router. We are going to create a simple network in Cisco Packet Tracer, and we will revise on everything what we have learned in previous tutorials of this Cisco Packet Tracer course. And the main purpose of this tutorial which I'm creating right now for you guys is so you understand everything in depth, as I will go through in depth and explain you everything what you need to understand about these things which we have learned. Firstly, we will understand IP addresses, how you can assign IP addresses, and how you can set up a subnet mask to the same network so all devices are on the same network. Secondly, we will have a look at ARP, or Address Resolution Protocol, and I will showcase how you can check ARP table on devices and how ARP works, or Address Resolution Protocol, which is also very simple, but I just want to go through it so you also understand it in depth. Then we will have a look at switch, how switch is using or storing MAC address table, and how MAC address table is changing when devices are communicating or broadcasting into the network. And then we will understand what is gateway and and why we even need this gateway IP address. And then also lately I will touch on one subject which we still haven't discussed in our tutorials, which we will deep dive in next videos, which is STP or spanning tree protocol. So you have a good understanding what is spanning tree protocol in general, like not in technical terms, but in general what it is and why we need spanning tree protocol. So let's start by building our network topology, where we will have only one router, one switch, and we will have 3 PCs. In the left bottom corner, click on network devices, and in second tab here on the left hand side, select routers. And we will be using router 1941 and click anywhere on workspace. And we will add this way our router. I will make it a little bit bigger. Let's add a switch and also make sure that in first tab here in the left bottom corner you are in network devices and select here switches. And we will be using switch 2960, which is very first switch. So click on it and click somewhere on workspace. And now let's add 3 end devices or 3 computers. So here in the very first tab select end devices and make sure that in the second navigation here is selected end devices and click on PC, and let's add 3 PCs. This will be our first PC. Let's click again on PC, our second PC, click on PC, and this will be our third PC or third personal computer. And now we can change this name so it is easier to understand that this will be PC1. The first one we will call PC-1, then second one PC-2, and third one we will name PC-3. So now in next step what we will be doing, we will connect our devices by using connections, and here in the left bottom corner select on connections, lightning icon, and here let's connect these all devices by using copper straight through cable. Let's start by our router. Click on router and connect it to gigabit Ethernet 0/0, and this is the just port, or name of the port is gigabit Ethernet 0-/0. This means that we have connected this cable to RJ45 port, which is called gigabit Ethernet 0/0, and then click on switch. And on switch let's connect this device to also gigabit Ethernet 0/1, which is here at the very bottom. So we have connected it. However, these two devices haven't established connection, as you know. Why it is happening from my previous videos, and we will establish this connection by configuring router. As you know, by default router needs to be configured, so it establishes connection with our switch. And now let's connect these 3 devices. And many things here in this tutorial I'm also repeating, so like I mentioned in this tutorial I'm just going through everything what we have covered in previous videos. However, I am going in depth so you have a good understanding what we are doing here. So again, let's select copper straight through cable, let's click on switch, and let's add our first device to fast Ethernet 0/1, and this is also just a port on the switch, name of the port on the switch, which is fast Ethernet 0//, which is RJ45 connection. So let's click on it and then let's click on PC and let's connect PC to fast Ethernet 0 port. And as you can see on PCs or computers or laptops, mostly there is only one of these ports if there is not installed additional NIC or network interface card with another port. Mostly all of the laptops or computers will have only one this port by default, and even with new laptops they might not have this RJ45 port at all. So you will need to use some USB RJ45 port adapter to connect a laptop. So let's click on it, connect first PC, also copper straight through cable. Let's select switch, let's add fast Ethernet 0/2, let's click on our PC, let's connect it, let's click on again copper straight through cable, let's click on our switch and let's click on fast Ethernet 0/3, and let's click on our first device and let's connect it. So now we have created a very simple network, and this is the network which you wouldn't be using in your home environment because we are using switch. This could be a network which you would be using, for example, in office or in some classroom. As normally if you would be using a home router, then access point, switch, DHCP and router itself, that would be only one device, and that would be called home router, because home routers or home environment you would not have a switch unless you buy a switch and you connect this switch to your router if you would want to do. However, in home environment you wouldn't do it, and that would be called like Soho environment or small office home office environment. Once we have physically connected all these devices, as you can see, we have switch and we have router. These are network devices, and we have 3 computers which are end devices or user devices. So first thing what we will be doing is we will be assigning IP address. But before we be assigning IP address, first we will add nodes. In the top left corner, let's click on place node and let's add nodes of IP addresses on all devices to which we need to assign IP addresses. And first one will be a router. So let's click under our router and let's type in IP address which is 192.168.1.1. And as you know from previous videos where I was explaining what router is about, so router is about connecting networks. Router is not about connecting devices, for example computers or providing Wi-Fi access, but the main purpose of the router as a networking device is to connect different networks together. For example, if we would build another network to the right, then this router would connect this another router and we would have 2 IP addresses on a router, where this first IP address which we are adding here for this network, that would be the gateway to all these devices which are on this network, as all devices which are in local area network which we are creating, they have only one gateway address, and that gateway address is that router's address, and all these devices in this particular network are communicating to router if they want to reach out to some other networks, or for example if they want to reach out to internet. However, if you would want to create just a local area network here and you wouldn't need these devices to connect to other networks, then you don't even need to use a gateway address. Like I mentioned, gateway address on the computer devices are used only to communicate to the router, so these devices can communicate to other networks, and this is the main purpose of the router, to allow local area network devices or some devices in some particular network to talk to other networks. In this scenario, this router address or this gateway address wouldn't even be needed. And this router's gateway address, as you can see, this is class C IP address. In general there are 5 classes, but all classes which you need to know is class A, class B and class C. If you haven't studied them, then go through and check out what are IP classes. So class A IP addresses start with 10, class B IP addresses start with 172 and class C IP addresses start with 192. And there are also APIPA addresses or automatic private IP addressing, and this means that if the devices doesn't find the DHCP server, they assign IP addresses to themselves, and those APIPA addresses usually are starting with 169.254. And I will also demonstrate you how this works in this network. Before we assign IP addresses, we will make these devices to assign APIPA addresses to themselves, because we will make these devices to search for DHCP server, and once they will not be able to find the DHCP server, they will assign APIPA addresses to themselves. And like I mentioned, APIPA addresses start with 169.254. This is also important to know. So there are 4 classes of these IP addresses. There is class A, class B and class C, and you need to know how to spot them when you are pinging devices or when you are using ipconfig command on some particular device, and you need to see them straight away and recognize straight away, because you need to understand on what type of network you are on, whether it's class A, class B, class C. Like I mentioned, class A starts with 10, class B starts with 172 and class C starts with 192, and the APIPA addressing starts with 169.254. Now let's add more nodes under our other 3 PCs. Let's click on node, and under first PC let's add a node, and we will be assigning the same IP range, which is 192.168.1.2. Let's do exactly the same under our second PC, 192.168.1.2. 192.1.3, and under our third PC let's also add a note 192.168.1.4. and as you know, switch doesn't need any IP addresses, as the main purpose of the switch is to allow devices to communicate with each other, and in comparison to router, the main purpose of the switch is to connect devices, and it is connecting devices based on MAC addresses, on device MAC addresses which are built into each device. So router is connecting networks based on IP addresses, and switch is connecting devices based on their MAC addresses. So let's return back to our IP addresses. Like I mentioned, we have three classes of these IP addresses: class A, which starts with 10, class B, which starts with 172, and class C, which starts with 192, and then we have a PIPA addresses. And now let's have a look how a PIPA addressing works. Let's click on this our first PC, and let's go into desktop, and let's click on command prompt. And here let's type in ipconfig. And ipconfig command is used to see the details on that device. As we opened our PC1, we want to see what IP addresses, what configuration is in this particular device. That's why we in networking we use ipconfig command. Typed it incorrectly, so ipconfig, and hit enter. And here we can see more information about our device. We have this IPv4 address, which are these 32-bit addresses. These are 4 numbers which are separated by dots, and each of this number and IP address represents 8 bits. This means that each IP address is 32-bit long, where IPv6 address is 128 bits long. And here, once we have typed ipconfig, like I mentioned, this is the command which is used in your own computer to see information about your computer, about network settings. Here we can see that we don't have IPv4 address, or we don't even have any default gateways here. And if you would want to see even more information than this, you can use the command ipconfig/all. So let's have a look what we can see if we type in ipconfig / and all. And if we click here, we can see much more information about this particular computer PC1. Here we can see physical address, and physical address is MAC address. This is the address which is burned into any PC or any computer, and there might be even more than one MAC address is on one computer. For example, if you have 2 NIC cards or network interface cards, then for each network interface card you will have a separate MAC address, and MAC addresses are 48-bit long addresses. Another thing which you can see by using command ipconfig / all is also you can see DNS servers to which is this particular device connected. And as you see, this is also not connected to anything. So we need to configure all this information. But before I even start configuring these IP addresses, I will show you a PIPA address. So let's open a computer, click into the desktop, and click into the IP configuration. This is where we can configure IP addresses, and as you can see, by default it is set to static. This means that we can manually assign addresses, but in real world scenario what would be happening: IP addresses, subnet masks, default gateway, DNS server even will be assigned by DHCP server to particular device. And DHCP server is domain host control protocol, which is assign IP addresses. And as you can see, I clicked there DHCP server, but we don't have in this network, as you see, we don't have here DHCP server. If you would be using a home router, then DHCP, like I mentioned, is built into the home router. So as access point is built in modern home routers, but in this router there is no DHCP built in. This means that if DHCP or domain host control protocol is enabled on some particular device, it will be searching for DHCP server. If it will not find DHCP server, it will assign IP address to itself. As you can see, once I clicked into the DHCP, it assigned IPv4 address to itself, and this is a PIPA address, which I was mentioning earlier on, and it assigned IP address 169.254. And these are the IP addresses. Like I mentioned, you need to know how to spot straight away when you are trying to troubleshoot some networks. So let's click again onto this second PC. Let's go into command prompt and let's type in ipconfig. and hit enter. Again, wrong information, IP config, hit enter, and now we can see that our IPv4 address in our scenario is 169.254, and this is what you need to spot straight away as, for example, network engineer. If you are trying to resolve some network connectivity issues and you don't understand why this or that device is not able to connect to network, maybe this could be disconfigured DHCP server, or DHCP server went down, or device is not able to communicate to DHCP server. And once the device is using this APIPA address, which starts with 169, which this device is assigning to itself, this means that this device, even if it will have a default gateway, it will not be able to communicate to outside network through router, because devices which have assigned to itself these APIPA addresses, they can communicate only with each other and on the same network. Now let's click on first PC, let's go into IP configuration, let's click into the DHCP, so this device will assign IP address to itself. We can check it by clicking again on this PC, clicking in command prompt, and here let's type in a command ipconfig and hit enter. And now we can see that this device assigned to itself 169, it has assigned to itself a APIPA IP address. So now let's click on this one, let's type in ipconfig, hit enter, and this device or second device also have assigned to itself a APIPA IP address. Now let's try to ping from this device which ends with .114.64. Let's try to ping this our first device. Let's go in, which ends with .39.20. So let's close this, let's open this device, and now let's ping 169.254.39.20. So we're pinging from our PC to our first device. Let's hit enter. And as you can see, pinging is going through. And to wrap this APIPA addressing, this means that the devices with self-assigned APIPA addresses, they are able to communicate with each other, but they will not be able to communicate outside the local area network, because devices which have assigned APIPA addresses can't communicate outside local area network. Like I mentioned, I am just going in depth in everything in this particular tutorial, so you have a good understanding about everything what we have covered previously. So next step, let's assign IP addresses to all these three computers or all these three devices. Let's click on first one, let's click into IP configuration, and now hopefully you understand why we don't use DHCP, we use static, and we will be assigning this IP address, which is class C IP address 192.168.1.2, and click into subnet mask. Subnet mask 255.255.255.20, so they are on the same subnet, and we will not be using default gateway yet, but if you want to connect outside the network, you can also enter a default gateway. If you want these devices to communicate only inside the particular network or local area network, you don't need to specify any default gateways or any DNS servers, because that is not needed, because these devices are communicating within the network. Or for example, DNS server you could specify if you would have some domain server within that local area network. As I have been creating a video on Active Directory and Windows servers, there you have a good understanding why we are using DNS server if we are connecting, for example, inside the local area network. Let's close this down and let's assign IP address to our second computer. Let's go into IP configuration and also static, and let's type in 192.168.1.3, and also click into subnet mask, and let's close this down and let's click into our third device. Click into desktop, IP configuration, and also make sure that it is static 192.168.1.4, and click into the subnet mask and close this down. So now we have assigned IP addresses. However, what we can see here, that our switch and router is still not able to communicate, and they still haven't established the communications. So next thing what we will be doing, we will be configuring this port on this our router. As you remember, on this router we use the port gigabit ethernet 0/0 to connect this switch to our router. And here to configure our router, router to assign this IP address to our router, which will be acting as gateway address. We can do it in two ways. First one is here in Cisco Packet Tracer. If you click on router, get into this config tab. This is the second tab, and here you will see this interface. And we have two interfaces, gigabit Ethernet 0/0. If we click into it, we can configure this, and we have another one which is gigabit Ethernet 0/1. But we need to configure this gigabit Ethernet 0/0 on this router RJ45 port, to which we connected our switch. Here in Cisco Packet Tracer we can do it in two ways. Whether we click just on router and we click here in interfaces gigabit Ethernet 0/0, and we can click here simply on, and here we add IPv4 address, and here we can also add subnet mask. But what we will be doing, we will not be doing this easy way. As you can see, if I switch off, then connection is not established. If I click on, then this connection is getting established straight away. But what we will be doing, I will show you, like in my previous videos in this Cisco Packet Tracer course, how we can do it using CLI, or how we can enable this gigabit Ethernet 0/0 port by using command line interface or CLI. If we click here on third tab on CLI, first thing, click enter. We created a very simple network. We added switch, we added this router, and we added 3 PCs or personal computers to this switch. And we assigned IP addresses to all 3 devices, and we checked connectivity between these 3 devices. And we also had a look at how a IP address is being assigned to the devices. And in this tutorial we are going to configure our router so it is able to communicate with switch. We will be assigning IP address to our router, which will act as gateway address to all the devices which are in this network. And then I'm going to explain you how ARP works, or address resolution protocol works, so as we will talk about MAC address table on the switch, and I'm going to demonstrate you how MAC addresses are being stored in our switch. So no further ado, let's get into it, and let's start by configuring our router. Like I mentioned in previous tutorial, to assign IP address to a router you have two ways here in Cisco Packet Tracer. One is if you click on the router itself, and if you go into config tab, and here you can select this gigabit Ethernet 0/0 port. If we just select this port or interface where we want to assign IP address, for example, as you can see under interfaces we have gigabit Ethernet 0/0. This is the port where we connected our switch, and there is another port which is empty currently, and if you would want to configure that, you would select this one, second one, gigabit Ethernet 0/1. But we will be configuring this gigabit Ethernet 0/0, and like I mentioned, here in Cisco Packet Tracer, by using this UI, you select this port and you click here on, and here you can assign IP address, IPv4 address. In our scenario that would be 192.168.1.1, and here in subnet mask you would assign a subnet mask which would be 255.255.255.0, but we will be doing it by using CLI or command line interface. So click into command line interface and hit enter, and here you can see that currently we are in router config if. Here type in exit, hit enter, type in exit again, hit enter, and now hit enter again until you are in router hashtag. Type in command configure terminal, and we need to type in this configure terminal command to enter a global configuration mode. Hit enter, and you will return to router configure mode. And once you are in this global configuration mode, here we need to select the interface which we would want to configure, and in our scenario, interface or port which we want to configure was gigabit Ethernet 0/0. So type in interface space and type in the name of the port, gigabit Ethernet 0/0. And by typing in this command interface gigabit Ethernet 0/0, we are simply selecting that port which we would like to configure, and hit enter. And to configure this port, what we want to do next, we want to assign IP address to this port which we have just selected with this command interface gigabit ethernet 0/0. And to assign this IP address, we simply type in command IP space address and space and then IP address which we would want to assign to this port. And in our scenario, the IP address which we want to assign is 192.168, as you can see here under our router, 192.168.1.1. And after you have entered the IP address, then space, and then we need to also specify the subnet mask. And subnet mask in our scenario is 255.255.255.0. Once we have assigned this IP address, hit enter, so this assigning is taking place. And now by using this command IP space address, we have specified the IP address and we have specified the subnet mask and we have assigned it to this particular port. And we can easily check it if we, for example, now would go here at the top to config tab, and we would click into this interfaces, and in our gigabit ethernet 0/0, as you can see, now IPv4 address is assigned. It is 192.168.1.1, and subnet mask is also assigned to this port. However, you will notice that this port is still not enabled, and as you can see here, if we look near the router, then this triangle or this connection is still not established with our switch. So we need to continue and we need to establish this connection between our switch and between our router, which means that we need to enable this particular port, or we need to switch this port on. So let's return back to CLI by clicking here on top on CLI and type in command no shutdown and hit enter. And once we have typed in no shutdown, as you can see, this port has been activated, or we have turned on this port, and now this is a connection between our switch and between our router is being established. And next command which we need to type in, because we have finished this configuration and we want to enter out of this configuration, we need to type in command exit, hit enter, and then exit again and hit enter. And now we have exited this configuration mode, and you can close this down. And now we have enabled connection. Now again we can click on our router and we can go into config. We can click into this gigabit ethernet 0/0 tab, and as you can see, port status, it is enabled. And if we look on IP configuration, we have assigned IP address and we have assigned subnet mask. But also if we go back to CLI or to our terminal, we can also check the status of ports on this particular router here from CLI or command line interface. As you can see, it again entered this config. If I will exit it again, exit, hit enter, exit again, enter, hit enter again to return back to router hashtag, and here I will type in a command show space IP space and interface brief. Hit enter, and here we can see everything what is happening with our router ports. Here interface, or this is particular port, like I mentioned, interface in Cisco Packet Tracer is the same as port. And here we can see that gigabit ethernet 0/0, we have assigned this IP address and there is also subnet mask, but here we can see that status is up. This means that this particular port is enabled and it has assigned IP address. So this command show IP interface brief, it tells you or allows you to check the status of the ports, what's happening to them, whether they have assigned IP addresses or not, or whether they are enabled or not, and close this window down. So next thing what we will be doing, we will take a look at ARP tables. And ARP tables are usually on the devices, on the computers. On end devices, we can check ARP tables. And to check ARP tables, I will be using PC3. Just click on your PC3 or PC or personal computer 3. And here click into desktop and go into command prompt. Type in command ARP and hit enter, and you will be able to see commands which are related to ARP. We have here two commands, ARP space -A and this command arp space -a allows you to check the arp table on your computer. You can do it even on your home computer. And then there is clear arp table. This is the command arp space -d. So two commands, one is arp space -a, which allows you to check the status or check what is happening on your computer with your arp table, and arp space -d, which allows you to clear the table. And next question is, what is arp? So let's check our arp table on this computer 3, arp space -a, hit enter, and you can see that there are no arp entries found. This means that this particular device, computer 3, from which we are running this command arp space -a, it haven't communicated to any other devices on this network. So to have some records in arp table, we need this particular device to establish connection to at least one of these devices on this local area network. And to do that, and type ping, and we can ping this second device, which is 192.168.1.3. So let's ping it, 192.168.1.3, and hit enter. And now you can see that pinging is taking place. This means that this particular device PC3 have communicated to this device PC2 on the same network. And now if we will run a command arp space -a, hit enter, you will see that in arp table we have now records. And here is what arp table stores: internet address, so it stores IP address and MAC address or physical address of that device to which this particular computer have been communicating. And in our scenario, as you can see from computer 3, PC3, we pinged the device PC2 and we stored the details of this PC2 in our arp table. And how arp works is very simple. When from the computer, for example 3 in our scenario, when we pinged the device 2, then PC3 first, before even pinging took place, PC3 sent ARP request. It sent ARP request to all devices connected on this local area network. And as PC3 didn't have any records in its ARP table, it didn't know the MAC address of this particular computer, which is PC2. So it broadcasted message to all network, and all devices on this particular network received this ARP request, where PC3 was requesting or asking to all network which device on this network has an IP address of 192.168.1.3, and this request was received even to PC1. PC1 checked that it doesn't have this IP address, which is ending with 3, so it didn't reply anything, and PC2 also got this request and it checked, oh yes, this is my IP address 192.168.1.3, which was requested by PC3, and it sent back to PC3 its IP address and its MAC address. And when this connection was established between the PC2 and PC3, PC3 stored the IP address and MAC address of this second computer in its ARP table. And here the main thing is to understand that these ARP tables are used to store the IP address and MAC address of those devices to which the particular computer have communicated on that local area network. So next time when PC3 wants to communicate, for example, to PC2, it doesn't have to broadcast that message to all network or all devices, and to not overload the network. So now next time when PC3 will want to communicate to PC2, it will know the physical address or MAC address of this second computer, so it will straight away will be sending a message, and it will be sending a message to the computer's to IP address and to the computer's to MAC address. So it will not be broadcasting that message to all devices which might be connected to that particular local area network. And this is why we need ARP, so to not overload the network, because when first devices are connected to some local area network, they don't know anything about other devices on the same network. And when they first try to communicate to some device on the same network, then they broadcast a message of IP to all network, to all devices which are connected in that particular local area network, and once they get ARP reply with the IP address and MAC address of that device which they wanted to connect, they store that IP address and MAC address in their ARP table. And next time when they communicate or want to communicate to the same device, broadcasting is not needed, so network is not being overloaded. And here you understand that if there wouldn't be this ARP table, then if the devices would want to communicate to each other, then each time they would need to broadcast this message out to all other devices on the same network, and network would simply be overloaded with all these requests every time when devices are communicating on the same network. That's why in networking we use this ARP, address resolution protocol, which is the protocol that is used to map an IP address to a corresponding MAC address or media access control address on a local area network. And remember, this ARP requesting and everything to do with ARP is only related to local area network. It has nothing to do with internet or anything what is going behind the router. So this ARP requesting is always happening before the router in the local area network, and this is only to not overload the traffic. I'm repeating myself again, just want to make sure that you understand it. So let's go through last one more time what is happening when you are pinging another device. When you are pinging another device from, in this scenario, in our scenario, from PC3, the ARP request, first, what's happening? ARP request is being sent to all network devices which are on that local area network. When that request is being received by devices, they are checking the IP address, where PC1 will say, no, the IP address which ends with 3 is not my IP address, it will not do anything. And PC2, when it will receive this request, or this broadcast which was broadcasted by PC3, it will see that it is its IP address, and then it will send back ARP reply. And in ARP reply it will also include its MAC address. As you can see here, it included its MAC address, and this MAC address and IP address, when it will return back to PC3, it will be stored in PC3 ARP table. So next time when PC3 want to communicate to PC2, it doesn't need to broadcast that message to all network to not overload the network, and it will be able to communicate straight away from switch to this second computer. And here, if we return back, you can also clear out this record. As you remember, here we have two commands which are related to ARP. One is ARP -A to check this ARP table, and another one is ARP -D, which is to delete pretty much all records in this table. If we click on that and then we run again ARP -A, you will see that this record has been deleted. This means that again, once we have deleted all these ARP, next time when we will want to connect to this device, PC2, it will be broadcasting the message to all network devices which are connected in this particular local area network. And local area network here is the keyword, as ARP acts or works only in local area networks, not on internet. And this is only to not overload the particular local area network with broadcasting every time to all devices, but establish the connection between particular devices. And if we ping again 192.168.1.3, or in this scenario, let's ping this .2, our first computer, and hit enter, we can see that pinging is taking place. And now again, let's run a command ARP -A, and here we can see that the IP address of this first computer is now saved in computer's PC3 ARP table, and MAC address also of this PC1 has been stored in PC3 table. However, when this pinging first time took place, the device PC2 also got this request or ARP request, and reply was only sent from this PC1. So now I hope that you understand how ARP works, how ARP table works, and why we need ARP request. So the main purpose here is to not overload the traffic with broadcasting every time to all all devices, and here is where switch comes in, because switch forwards traffic based on MAC addresses, and every time whenever some device is connecting to the switch, in this scenario when from PC3 we send a request from PC3 looking for PC1, when we broadcasted message, straight away switch stored information or MAC address of this computer in its MAC table. So it knows that this particular computer 3 in our scenario, is connected on that particular port on switch, and when PC1 sent ARP reply, switch associated the port of PC1 also to its MAC address. Switch straight away knows that PC3 lives on that port and PC1 lives on that port, and we can also check it by checking a MAC address table on our switch, and I will show you how we can do it. So let's close this. If we now click on switch, if we go in CLI or command line interface of our switch, hit space until you will get switch with closing triangle bracket, and here type in a command show MAC address table. Show space MAC space address dash table, so we can see what devices live and on what ports on this particular switch. So hit enter, and here we can see that on this switch we have 3 connected devices. 1, 2, 3. MAC address for the device which lives on gigabit Ethernet 0/1. This is probably our router, because we connected our router, as you remember in previous tutorial, to gigabit Ethernet 0/1 port, and in this scenario our router's MAC address is this one. And here we can also see that device is connected to port 01, where we connected our first computer. It has a MAC address of 2714, and we can check it straight away that MAC address ends with 2714. So let's click on this device, let's open desktop, let's open a command prompt, and here let's type in ipconfig space /all and hit enter, and now we can see the MAC address or physical address of this first computer, and as you can see the MAC address of this first computer ends with 2714. If we go back into switch, so switch knows that to this port, which is port 1 on this switch, has a MAC address which ends with 2714. Switch also knows that on this third port, which is for PC3, the device which is connected to this port or to this interface on this switch has a MAC address which ends with 3860, and we can also check it by clicking on our third computer, clicking into command prompt, and here let's type in again ipconfig space /all and hit enter. And now if we have a look at MAC address or physical address of this device, we can see that it ends with 3860. So now switch knows about these 3 devices, but it doesn't know anything about this device because we haven't done anything with this device. So what we will do now, let's try to ping from our computer 3 this computer 2. So switch also knows which device lives on this port. And now once we will be pinging from this computer 3, once we will be pinging this computer 2, and computer 2 will be sending back ARP request, it will be sending ARP request along with IP address and with its MAC address. And once switch will receive MAC address of this second computer, it will also store and will know that this computer 2 lives on second port on this switch. So let's do it. Let's open a computer 3. Let's try to open command prompt, and now let's ping, and let's ping this computer with 192.168.1.3. so 192.168.1.3 and hit enter. And now connection is being established. This means that now we pinged from our computer 3 this computer 2. So let's open this down and let's click on switch, and now let's run here on switch again this command show space MAC space address dash table. Let's click enter. Here we can see that now switch knows that on port 2 there lives a device which ends with 7240. And to check this, we click on this second computer, go into desktop, go into command prompt, and let's type in ipconfig all space /all and hit enter. And let's check the physical or MAC address of this particular device. As you can see, it ends with 7240. Let's close this down. Let's go back to switch. And here we can see that in this MAC address table, it also knows that on port 2 there lives this device 7240. So this is our second computer. In my previous video I was explaining this, that routers are used to send traffic based on IP addresses and switches are sending traffic based on MAC addresses, which it is storing in its MAC table. And switch stores MAC addresses of these devices and it associates in this MAC table these device MAC addresses with its ports, so it knows on which port which device with which MAC address lives. And then when next time these devices want to communicate, switch straight away forwards this traffic because it has in its MAC address this information that device 1 or computer 1 has that particular MAC address and it lives on that particular port or interface on that switch, and broadcasting is not needed and switch is able to easily forward traffic between the devices connected to that switch. So yes guys, hope that now you know how to configure router using CLI, what is ARP table, what are ARP requests and what are ARP replies. And in this tutorial of this Cisco Packet Tracer course we are going to configure a DHCP or Dynamic Host Configuration Protocol server on a Cisco router using Cisco Packet Tracer. And today we will be configuring DHCP on a router. In next tutorial I am going to show you how to attach a DHCP server to our network and how we can configure DHCP server as a separate device. And here main thing to know about DHCP is that DHCP or Dynamic Host Configuration Protocol allows devices automatically receive IP addresses, subnet masks, default gateways and DNS information from a central server. And main purpose of DHCP is to assign all this information so network administrators don't have to do it manually for each device which is connecting to particular network. And in this tutorial I'm going to show you how to create a pool of IP addresses which DHCP server can assign to devices, and I'm also going to show you how to create a reserved IP address from this IP address pool. For example, if you wouldn't want to allow that IP address to be assigned to any of the devices, and we will be using CLI or command line interface to do this. So first let's create our network topology where we will have one router, one switch and 3 PCs. In the left bottom corner click on network devices and in second navigation in left bottom corner make sure that routers are selected, and here to the right let's select the last router which is 2811 and click somewhere on the workspace to add this router. Then again let's click on network devices and in second navigation here in the left bottom corner select switches. And let's select very first switch which is 2960 and also click on the workspace to add that switch. And now let's select 3 end devices. So in first navigation in left bottom corner click on end devices and let's add 3 PCs. So click on PC, click on the workspace and similar way let's add another 2 PCs. And now let's connect all these devices. Click on connections in first tab in the left bottom corner and select copper straight through cable. First let's click on router and on router let's select fast Ethernet 0/0 port. And then click on switch, select fast Ethernet 0/1 port. And similar way, let's click on copper straight through cable. Let's again click on switch, select fast Ethernet 0/2 port. And let's click on our first device. Let's connect it. And let's do exactly the same with our other devices, fast Ethernet 0/3 port. Let's click on PC1, fast Ethernet 0, and again copper straight through cable, click on switch, fast Ethernet 0/4 port, and let's click on our last device and let's connect it to fast Ethernet port. So now we have connected all our devices, and here on this router we also have a DHCP. Here also important to note is that the main purpose of the router is not to have a DHCP. Things like DHCP or access point are usually separate devices in a large networks. However, in home routers or in some routers, DHCP server is also built in. So in next step we will be configuring our DHCP server on our routers, so as we will assign a gateway address to our router, and gateway address, as you know, is needed for devices to communicate to the router so they are able to communicate to other networks which are connected to the router. So as we will enable router, so it establishes connection with our switch, and we will configure DHCP server also on our router. And to do that, let's click on our router and let's click into the CLI or command line interface, as we will be doing it on command line interface. And here you can see it is asking in my scenario, would you like to enter the initial configuration dialog? Here I will type in no, hit enter, or you can hit enter if you don't have that until you will get to router and triangle bracket. Type in enable, so we enter a configuration mode. Enable, hit enter, and type in next command, configure terminal, and hit enter. Now we have entered the configuration mode. First thing what we will be doing, we will be assigning IP address to the port where we connected our switch. And as you remember, we connected our switch to fast Ethernet 0/0 port on this router. So we need to assign IP address and subnet mask to this port. Who are watching my videos, you already know these commands from my previous videos. This is the command interface, as interface is the same as port. In Cisco Packet Tracer or in Cisco, those are interfaces. So interface space and the name of this port, which is fast Ethernet 0/0. So by this command interface and then interface name or port and port name, we are simply selecting this port and hit enter. And in next step we need to assign IP address and subnet mask, and to do that we type in command IP address space and specify IP address, and in our scenario IP address will be 192.168. This will be also a gateway of our router .1.1, and space and subnet mask will be 255.255.255.0. And by using this command IP address, as you already know, we are specifying IP address and subnet mask to this port on our router, and hit enter. And now we have assigned IP and subnet mask also to that port. But next step we need to also enable this port. To enable the port we type in command no space shutdown and hit enter. And as you can see, once we hit enter, this port has been enabled. Now it is green and it is establishing connection with our switch. So we have assigned IP address. I will actually close this down. Let's place a note under our router so you know the gateway address, and it was 192.168.1.1, and it is a gateway and our router's IP address for this local area network. Now let's click again on our router. Let's go into CLI. As it enabled, our router state is up, not down, as you know from previous tutorials, guys. Then if state is up, this means that port is enabled. So now we need to assign a DHCP pool. This means how many IP addresses DHCP server will be able to use to assign IP addresses to devices. First we will need to create a pool name, or our DHCP IP pool name. And to do that we type in command IP space DHCP space and pool and space, and then you give a pool name. I will be calling my pool LAN_pool. You can call your pool however you want. I will call it just for the purpose of this tutorial with this command IP DHCP pool, and then you give a pool name of the IP addresses for this particular DHCP server and hit enter. And with next command we need to specify the range. To do that, type in network space and 192.168.1.0 and subnet mask 255.255.255.0. And by this command network we are specifying that we will be giving all this IP range with this subnet mask. And here you know that if we are giving all pool of IP addresses of 192.168.1, then we will have available 254 usable IP addresses for DHCP server, so it is able to assign these 254 IP addresses to devices, and hit enter. And with next command we also need to specify the default router of our DHCP server, and to do that we type in command default -router space, and we need to give this router's IP address, which was 192.168.1.1. So let's do it. 192.168.1.1. Hit enter. Actually there is a problem. As you see, I didn't type in default, I didn't specify the T letter. Default -router space 192.168.1.1 and hit enter. And now we have also assigned a default router to this DHCP server by using this command default router. And now we can also specify the DNS server for all these devices. For example, if you would want some particular DNS servers to all those devices which get assigned this information, like routers information, DNS server information, and default IP address from this 254 IP address range. So to assign a default DNS server, I will assign Google's DNS server. We type in a command DNS-server, and Google's DNS server is 8.8.8.8 and hit enter. And now with these commands we have assigned IP range from 192.168.1.1 with subnet mask 255.255.255. We have 254 available IP addresses. We have assigned the default router for this DHCP, and we have assigned all default DNS server. And once we have done all this configuration, we type in a command exit and we hit enter. So we exit this DHCP configuration mode. And for example, if you would want to also exclude some IP address, like I mentioned, you can also do it by the following command. You type in IP space DHCP. As we already, in previous commands, we already have specified the pool of addresses which this DHCP have. And here type in a command excluded -address. And in our scenario I will exclude the IP addresses which is one assigned for our router, which is 192.168.1.1, and I will exclude 10 IP addresses to 192.168.1.10. And to do that we specify IP address range 192.168.1.1 and then space and then ending IP address to which we want to exclude, which would be 192.168.1.10. So all this range of IP addresses from .1 till .10, these are excluded IP addresses from this pool which we have defined, which is 192.168.1.1, where we had 254 IP addresses. Now 10 IP addresses we have excluded. Hit enter. And now we can close down this configuration, and then we can go and configure IP addresses so they are obtained by our devices. So I will click on our PC1, which is our first computer. I will click into desktop, and here click into IP configuration, and here we can see that configuration by default is static. If we click into DHCP, it is automatically assigning IP address, and as you can see here, IPv4 address in our scenario. As you know, we excluded IP addresses which ends with .1 to .10, and it assigned the very first available IP address, which is .11, and it assigned also subnet mask, and the DHCP server also assigned this default gateway, which is the 192.168.1.1, which is here, and the DHCP server also assigned a default DNS server, Google's DNS, which is 8.8.8.8. And let's close this down. And now let's do exactly the same with PC1. Let's click on it, go into desktop, IP configuration, and now if I will enable the DHCP server, probably this IP address will end with .12. So let's enable the DHCP server, and here you can see that this IP address is assigned with .12 192.168.1.10. 12 because this is next available IP address in our DHCP servers range, where we allowed all IP address range and then we excluded from IP address .1 till .10. So this computer got .11 and this second computer got .12 IP address and the same default gateway and DNS server. And let's do exactly the same to our third device. Go into desktop, IP configuration, DHCP server, and this would be .13. So our DHCP server is working and it is assigning IP addresses, subnet masks, default gateways and DNS servers to our network on our router. And in this tutorial of this Cisco Packet Tracer course, we will create a network in Cisco Packet Tracer consisting of dedicated DHCP server, a router, a switch, 2 PCs and a printer. And we will configure our DHCP server. We will configure also our router using CLI. And in this tutorial you will also understand what are dynamic IP addresses and what are fixed IP addresses. And we will reserve 10 IP addresses from IP address pool which we will assign to DHCP server so we can use them as fixed IP addresses. And for our printer we will use a static IP address from reserved range of these 10 IP addresses which we will reserve while configuring our DHCP server. And this will reflect real world best practices where printers are typically assigned the static IP address to ensure consistent access. And one of the key reasons for reserving a range of IP addresses in DHCP configuration is to accommodate devices like printers or, for example, routers which benefit from fixed IP addresses. So let's start by setting up our network topology, and we will start by clicking here in the left bottom corner on network devices, and in second tab make sure that you click on routers. To the right here we need to select our router, and we will be using router 2811. And this is the last router here, so click on this router, click somewhere on workspace so we add this router. I will make it a little bit bigger. Next we need to add a switch, and we will be using switch 2960, so also make sure you are in network devices, and here in the second tab select switches and select switch 2960, which is first switch, and click somewhere on workspace. And to add a server, here in the left bottom corner click on end devices, and to the right here you will see server. Click on server and click somewhere on workspace. I will add my server here, and this will be our DHCP server. And now let's add also here, while we are in end devices, 2 PCs. So click on PC, click on workspace and click again on PC and click on workspace again. And here also in end devices click on printer-pt and click somewhere on screen. So now we have all devices, and now let's connect them with copper straight through cable. So click here in the left bottom corner on connections and select copper straight through cable, and let's click on our router, and on router let's select port fast Ethernet 0/0. So remember the name of the port, like I'm always mentioning in these tutorials. Remember, these are the names of the ports. So click on fast Ethernet 0/0 and click on switch, and we will connect our router to our switch on fast Ethernet 0/1 port. Click again on copper straight through cable. Let's click on our switch. Let's click on fast Ethernet 0/2. Let's click on our server and let's connect it to fast Ethernet 0. Now let's connect all the other devices. Copper straight through cable. Click on switch. Fast Ethernet 0/3. Click on first computer. Let's click on fast Ethernet. Click again copper straight through cable. Fast Ethernet 0/4 on our PC1. Fast Ethernet, and let's click on copper straight through cable to our switch fast Ethernet 0/5, and let's click on our printer and fast Ethernet 0. And now let's add a note under our router what IP we will be assigning to this router. Click here in notes in the right top corner. Let's click under router, and to this router we will be assigning IP address 192.168.1.1, and this will be also our gateway address. We are adding this IP address so we just can visualize and see our IP address. So as we will be assigning IP address to server, as server also needs to have an IP address on network. So again, let's click on node and let's click under our server, and let's add an IP address 192.168.1.2. When you have a DHCP server, you also must have IP address for our DHCP server. And here, as you know from our previous tutorials, the connection between our router and between our switch is not established because of the reason that we need to assign a port, the port which we connected, which was fast Ethernet 0/1 on our router, and we need to give an IP address to that port, and we need to turn this port on our router. And this IP address which we will assign to this port on our router, this will be also a gateway address to our devices on this local area network whenever they will want to connect or communicate to outside networks. And now, once we have set up our network topology, let's configure our router, and we have been doing it already in our previous tutorials. So to configure a router using CLI or command line interface, click on router. You could configure this router, like I mentioned, just by going into the config tab and clicking into this interface. As you see, under interfaces we have these two ports or two interfaces, where one is fast Ethernet 0/0 and another is fast Ethernet 0/1. You could add configurations to these router's ports here by using this user interface. However, we will not be doing it, and like I mentioned, we will be configuring fast Ethernet 0/0 port, as this is the port on our router to which we connected our switch, and currently this connection is not established. And here is IP configuration, where you can configure IPv4 address for this port on this router, and where you can add subnet mask for this router. And if you want to enable, here is port status, you could click on. However, we will be doing this using CLI, so click into the CLI. Currently we are in router config if, exit. So we exit this until you will get to router config mode. But if you are not here, type in exit again, and you type in exit again until you will get to this mode, router triangle closing bracket. Type in command enable and hit enter, and then type in configure terminal and hit enter. I made some mistakes, so type in configure space and terminal and hit enter. Now we have entered that configuration mode. What we need to do, we need to select this port on our router. If you are watching these videos, you already know how to do it. We type in a command interface and this interface name, space and this port's name, and this port's name was fast Ethernet 0/0, and hit enter. And by typing in this command interface fast Ethernet 0/0, we have simply selected this port on our router. We are saying port, select this port fast Ethernet 0/0, and now we want to execute some action on this port. And in our scenario, we want to assign this static IP address to our port. So to assign IP address, we type in command IP space address, and we specify the IP address and subnet mask for this particular port, and that will be 192.168.1.1, and then space and 255.255.255.0. Here, like I mentioned, we are specifying IP address for the port which we have selected with previous command. And once you have done this, hit enter, and IP address and subnet mask to this port will be added. And if you want to check it, you can go back here in the top on config tab, and under interfaces select fast Ethernet 0/0 port, and you will see that IPv4 address. Currently it is added, and subnet mask is also added. However, this port is still not enabled. You can see it here that port status is not check marked. Like I mentioned, you could check mark it here manually, and here we can see this red, that connection between our switch and our router is not established. So in next step we need to establish also this connection. So let's go back into our CLI. Let's enable this port, and to enable port, we use a command here in CLI no space shutdown and hit enter. And once we will hit enter, this port automatically will be enabled and or turned on, and connection between our router and switch will start establishing. Let's hit enter. The red triangle turned into green, and this connection between our router and our switch is being established. We have configured our router. Let's configure also our server, and for server server, first thing what we need to configure is its static IP address. So let's start by assigning this static IP address to the server, and to do that we need to also, similar way as we assigned the port to our router, to assign this IP address or static IP address to port on our server. And on our server the port was fast Ethernet 0, so let's click on the server, click on config, and here under interfaces you will see this fast Ethernet 0. And click into this fast Ethernet 0, and this is where we can assign this static IP address for this port on our server, which is 192.168.1.2, and this is static or fixed IP address. Make sure that in IP configuration you are clicked into the static, and where it says IPv4 address, in this field let's assign this address 192.168.1.2, and in subnet mask click in and it will get populated automatically. If it doesn't, then we assign 255.255.255.0. And now we want to create IP address pool, which this DHCP server in our scenario will be able to assign to all other devices on our network. And to do that, click into services, and here under services you will find DHCP. So click into the DHCP, and here you will see interface fast Ethernet 0. Make sure that this is selected, and here make sure that this is turned on. So service is turned on, and here where is pool name, usually we give a name to this IP address pool which we are giving to DHCP server, so that DHCP server can use this pool of IP addresses to assign them to devices on our local area network. I will call this pool LAN or local area network underscore pool. You can call this pool however you want. In next step we need to specify default gateway address, and our default gateway address for this server is 192.168.1.1, which is a router's address. Once we will specify default gateway address here this default gateway address will also be assigned by DHCP server to all other devices on this network, which will be obtaining IP address dynamically from our DHCP server. So let's click into our DHCP configuration, to this DHCP service configuration, and let's assign this default gateway, which is 192.168.1.1. The starting IP address, as you can see, 192, it populated it automatically, 168.1.0 with subnet mask 255.255.255.255. Here we have specified the range of IP addresses with its subnet, which this DHCP server will be able to assign to devices on this local area network. If we have 192.168.1.0, this means that we will have 254 available devices on this particular network. And first device which will be assigned by this DHCP server will start with IP address of 192.168.1, and here will be not 0 but .1. However, this is already reserved for our router with .1, and with .2 it is already reserved for our DHCP server itself. So it will start assigning, for example, for first computer IP address with .3, and actually I will leave it, and then later I will show you how you can configure this so you can reserve first 10 addresses so you can assign them manually to the devices which require static IP addresses. Like I mentioned, one of such would be router, because you don't want this IP address to be changed once you assign it to a router as a gateway address. So as you wouldn't want this server, DHCP server's IP address to be changed as well, so that also should be assigned manually, and that should be a static IP address. So as for our printer, that also should be a static IP address, because as network administrator we don't want our printer's IP address to be changed or to be dynamically assigned by DHCP server, as that way we can make sure that these devices or users on that local area network, they will always be able to connect to our gateway, will be always able to connect to DHCP, and they will always be able to go to printer by the same IP address to use that printer. I will leave it as it is, And I will close this down, and now let's click into our first PC and let's click into desktop and let's go into IP configuration. Here by default it is set to static IP addressing, and here we will click into the DHCP, and once we will click into the DHCP, that DHCP server, as you can see, assigned IP address, and it assigned IP address 192.168.1.3, and this is a dynamically assigned IP addresses where we to our router assign static IP address. This IP address to our router is not obtained by DHCP server. So as the IP address which ends with .2 we assign to our server. So the first available address in this DHCP IP address pool ends with .3, and that's why it assigned it automatically to this PC. But now, for example, if we would want to reserve on DHCP server first 10 IP addresses, so we can assign them only manually as static IP addresses to all devices which we want, like routers, servers, for example, or printer in our scenario, which we will do a bit later, then we need to modify this DHCP address pool. So I will click now back to static here for this first computer. I go back to our DHCP server, click on server, click into DHCP here, and here in service make sure that it is turned on, and to reserve first 10 IP addresses, here where it says start IP address, at the end instead of 0 type in 11. So it starts assigning these dynamic IP addresses for the devices which use DHCP to obtain IP on this local area network, so they will start obtaining IP addresses starting from 11. Where is DNS server? There I will enter 8.8.8.8. So this DNS server will be Google's server, and click here on save. Let's close this down. Let's go to our first PC. Let's click on it, let's click IP configuration, and here select DHCP. By default it is static. Let's select DHCP, and you will see that now IP address which is assigned is 192.168.1.11. This means that it starts assigning IP addresses, and we have reserved first 10 IP addresses. Now in DHCP pool there is not anymore 254 available IP addresses, but there is only available 244 available IP addresses in this range. If we click back into our DHCP under the services, as you can see it starts with 11. So if that is 0, this means that we have 254, and here you can also see that maximum number of users is 245. This means that it can assign only 245 or 244 to be exact IP addresses to devices on this network. And now we can do exactly the same. So let's click on our second PC, which is PC1. Click here into desktop. Let's click IP configuration, and this should end with .12. Let's select DHCP. So DHCP assigns IP address, and DNS server, as you can see, it's also assigned by DHCP server as it is in real time. And here we can see that IPv4 address is 192.168.1.12. So we have created this pool of IP addresses, and we reserved first 10 IP addresses for devices which we want to assign manually, or to create these static kind of IP or fixed IP addresses, like for router, for server itself. And now if we click into printer, we click into the config tab, and we also connected this printer to on this port fast Ethernet 0. You also click into it, and here we can assign its static IP address. We could allow DHCP server to assign it. If we click on DHCP, that would be like .13, as you can see, but we don't want DHCP server. Like I mentioned, in real world scenario, printers would have a static or fixed IP addresses, so they are not changed based on time zones or on time which is specified by DHCP. So we want a static IP to be assigned to our printer, and here we can assign IP address, one of the very first ones which we have reserved. So for our router we assigned IP address which ends with .1. For our server we assigned IP address which ends with .2. So for our printer let's assign IP address which ends with .3. So 192.168.1.3. and subnet mask the same 255.255.255.0. And let's close this down. Let's make sure that our devices are able to communicate. So we will open the very first computer. Let's open a command prompt and let's try to ping our printer, for example, because printer is also on the network and it should reply anyway. So type in ping space 192.168.1.3 because we assigned this IP address to our printer, and hit enter. And as you can see, printer is replying. This means that these two devices are able to communicate. Now we can also ping our second computer where we had assigned IP address. If I click into it, let's go into IP configuration. And here you can see DHCP assigned IP address which ends with .12. So let's go back on our first computer and let's ping the IP address, like I mentioned, 192.168.1.12 and hit enter. And as you can see, pinging is also taking place. So the devices on our network are able to communicate and the DHCP server is assigning IP addresses. So as we excluded first 10 IP addresses, we reserved them for the devices where we want to assign manually static IP addresses for devices like routers, printers, or for example servers on network. So yes guys, hope that you found this video useful. If you did, leave a like, share this video, subscribe to the channel if you are new, and see you in the next one.